So right now we actually want to return back the found variable. So we have two options here. We can return back found, or we can simply take this and return it back in here. We don't need to run this code to see if it's found or not and then store it and then return it after. Since we're not doing anything else with it, we could just return it like this. This makes the code considerably shorter, because this will just return back a true or false. If the index is greater than -1, then it will turn back true. If the index is less than -1, then it will turn back false. So let's see how we can use this function inside our code now. So we wanted to search for milk, so let's just copy and paste this line, and let's see if we can get the same output as the shopping list index of. So now our function is called findInList. You have a bracket, and then our string s is going to be our milk, our list is our shopping list, and our out int index. So this is going to return us back with a boolean, so we can print that boolean to the screen, and then if we just duplicate that down, and we can print index to the screen, and maybe using a console write line and just place a space right at the start. So we print out whether it's successfully converted or not, and we get the value back from it. Let's run the code. So we get true plus the value of 1. So that means it's found it, and it's found it at 1 index, and the previous line before it, which just run the normal index of function, also return back 1, so they're both the same. Let's just get rid of that space. So if we change this both to coffee, then hopefully we should see the same result, but with index 0. There we go. This 0 comes from the index function, this true is from our function telling us it's been successful, and this 0 is the index. So we can actually take this and put this straight into an if statement. So just like we had down here with the found and not found, we can say if, and then this function call, and then we can say found, and then the item what we passed in, so in this case it's going to be coffee, found coffee at index. And if it hasn't been found, then we can just print not found. And this is getting an error because we have two indexes up here, so let's comment out this line, and let's try running now. Found coffee index 0, and you can see these two are the same again. One comes from here, and one comes from that index. If we change these both to milk now, milk, and milk, then run the code, and you can see found milk index 1. If you wanted to, just before you pass in here, you can ask the user, enter an item to search, store it inside string search equals console.readline, and then instead of passing milk in here, we can just pass in search, and then instead of passing milk in here, we can also use the search variable. So now if we try running again, we can type in milk, and there we go, found milk index 1, and then coffee, found coffee index 0, and just to give this a test, let's just try and find M, not found. Perfect. So let's have a little recap based on this function. So initially we tried to assign the value of 0, and then print out a normal function, and inside test, we just had a simple num equals 5. And what this was doing inside is just locally assigning it, but not actually return anything. And then we said we could assign it and then return it back, and that was another option of being able to assign the value to 5. And then we used the out parameter, which allowed you to pass in an integer. When you assign it in here, it will pass it back into the original call and place it in this variable here. So when we print it out on the next line, it says it's equal to 5. We wrote our own little shopping list for the list of strings, and then we called the shopping list function index of, and then we actually created our own index of function and made it into a function. So just a little recap of what's going on here. We have a string s, which is our search term, the list full of the items in the index that we're going to pass back to the user, as well as returning back a bool to indicate whether we found it or not. We set the index to -1, so then that completes our logic at the bottom. -1 means it hasn't been found since the list is all 0 based. If this value is greater than -1, then that means that we found it inside the list, since the list is 0 based. And if it's not that, and this returns back false, then we mustn't have found it, because this line would have executed. So we loop through the list, we do a lowercase comparison on both sides of the equation, on the list item and on the search term. If they both match, we run the index and store the I variable inside the index, and then we return whether index is greater than -1. So after we return this back from the end of the function, we can see once we run it inside the console write line, this is just going to return us back with a true or false value, as well as creating our new integer variable called index. So on the next line, we can use index and print it out to the screen. This line should return true or false, since it's a boolean return, and this variable will either give us -1 or something above -1. But in this case, when we actually make use of the function, we can ask a user to enter something, get them to type it in, and pass that into the function. But more importantly, when this function returns, if it's true, we output it's been found, and if it's false, we output not found. And we only make use of this integer variable should this return back true. There is no point in printing -1 to this screen because that's what you're going to get if it's not found. It's going to look something like this, which is kind of redundant because the user doesn't care about this. So we don't need to include it when we're printing not found, but we should include it when we're printing out the found. Of course, this is just a random example and you might not need to print it out to the screen, or you might just do something else inside here. You might be searching for something and then you might want to edit it or do something else with it, and then you can make use of that index. If you wanted to ask the user to search for an item and then tell them what they want to replace it with, then you can also do that, just as we've covered in the last examples. So after we've covered out parameters and normal parameters, let's have a look at a concept called passing by reference. So we created int num equals 10, and let's call it assign, and we passed it straight into here. And we can have a static void assign int num. If we say num equals 20, if we use a console write line up here, then num is still going to be 10. Because we're not returning it and we're not really affecting it. Now other ways we can do this is by changing this into an int, and then we can say return 20, and then we don't really need this anymore, so we could just say num equals assign, and then we'll get 20 assigned back in. There we go. Or we can actually make this an out int num, and then we can say num equals to 20, and then inside here we can say out num, and we don't need to return back an int anymore, so we can make this void, and you can see the value is 20. So there are different ways that we can assign a variable straight from here. So let's have a look at another method. So instead of having out, we can actually use this new keyword called ref. And the reason why it's ref, it means it's passing it by reference. So when you pass a value in through a parameter normally, you're actually passing by value. And what that means is, you're copying this value that gets passed inside the brackets into here, and it's making a whole new variable. What I mean by that is, this might have memory address location 1, and then when this variable gets created, it has memory address location 2, for example, and then it's used within here, and then 2 is now deleted because you've got rid of the variable because of this function, but 1 is still live since in the main function. When you pass by reference, what you're doing is you're saying, give me the memory address location of the variable inside the brackets and give it into this function rather than copying the value. So if this has memory address location 1 and you pass it into here, then it's also going to have 1. So what this actually means is, if we put this ref keyword just before the int, just like we do with the out, and we can place it here as well, we're now saying we want to pass this by reference. So when this 10 gets passed in here, we actually have a link, if you will, to this num is now linked to this num. Which means if we simply do num equals 20 and run the code, then we're going to see 20. The main differences between reference and using the out keyword is when you're using out within a function, you actually need to make use of the value. If I don't include anything within here, then I'm going to get an exception, and it says the out parameter num must be assigned. So when using the out keyword, num has to be assigned. When using the ref keyword, you don't have to make any assignment because we're just passing a reference in. With the out keyword, you'll literally tell the function, I want to output this value. But if you haven't gave it a value to output, then of course it's going to be an error. So we can assign it in the reference if we really want to. But you don't have to, and it's not required. So they're the two main differences between passing by reference and passing by value, and also using the out parameter. Passing by reference is technically quicker because of efficiency. When you don't pass it by reference, you pass it by value, which means it'll essentially place that 10 inside these brackets. Instead of passing the variable in, it actually just passes the value, and then it makes a whole new variable down here. When you pass it in by reference, you're essentially actually giving it a link to this memory address location from inside this function, which means that you don't actually have another local variable inside here because this one is affecting this one directly. You can do this with any amount of references you want by simply just chaining them and adding another one in. Like that, for example, and then we can have a string name, and then we can pass our ref name inside here, and then inside here we can say name equals Abba. And this doesn't like it if it's unassigned, so we just give it empty quotes, or we can assign it another name, it doesn't really matter, it's just a demonstration. And if we run that, but let's just print out the name as well to the screen. There we go, we get ABBA assigned into there. And same thing with this variable is we're actually just passing in the variable as a reference rather than as a value. It doesn't matter what the value is going to be because it's just given this variable inside this function. So we're actually saying name equals, we'll basically just assign it back into the original variable. So let's just have a look at another example. So we can have some sort of like change name function, and we can give it the name variable as a reference, and then we can give it the new name that we're going to pass in a second. So if we make a new function, static void, change name, we're going to need a ref string name and a string new name. And we can simply say in here, name equals new name. Perfect. So let's give this a shot. So if we just comment out this little section, and we can say console write, enter your new name, then we have a string, new name equals console.readline. And then just up here, as we've done before, we could just declare the name as being Joe, and then we enter the new name, call this function, and then after we can say your new name is, and then we can pass in name. Perfect, let's run that. So at this point, the name is actually Joe, because we've made it appear, and then we'll enter a new name, so we can type in ABBA. Now it says your new name is ABBA. Perfect. So all this function's doing, I know it's pretty pointless right now because it's just doing one line, but all it's doing is assigning the reference to the variable that we pass in. So what we can do now is make sure that we can actually assign this variable in, and we can also pass in a Boolean variable. So what we should do now is actually make sure that we can do the assignment properly, because you don't want to assign it if the value is empty, and then return back a Boolean type just to indicate whether or not it's being assigned. So what we can do in here is just on the change name, we can wrap this around an if statement, and if this returns back true, then your name has been changed, and if not, we can say console write line, new name cannot be empty, or null. And in order to be able to do this check, as we've used before, we could say if new name, and then just around that we can say string.is null or empty and wrap that inside the brackets, and we want to say if it's not null or empty, then we want to do our assignment. After we've done our assignment, we can return back true inside here, and then just outside we can return back false. Notice how in this little bit of code we actually don't have an else. We don't need to write else inside here and place return false inside here, because if this returns back true, then it's going to execute this one line, return back true, and since it's a return, it's going to jump to the end of the function. So we don't need the else in there, because the only way that this line will ever execute is if we actually had this function returning back false. So if this returns back true, it's going to hit this line, hit the return, jump to the end. If this returns back false, it's going to skip over the if statement and then just return back false to the user. Perfect, so now we've got no compile errors, let's give it a run. So if we want to change the name to nothing, if we just press enter, then we can see it says new name cannot be empty or null. And if we type something in, then we get our name changed. So just to round up this video, let's talk about the main differences between the ref parameter and the out parameter. When you assign it by reference, you actually have to make the variable before you pass it in. For example, you can't just write ref string in here and that actually works. Whereas you can't actually do that with the int. Let me demonstrate. So if you had the int.tryParse and that has an out parameter, you can actually type out int index inside here. You don't actually have to make the int index inside here and then specify it outside. You could just initialize and declare the variable straight inside the brackets, whereas because you're passing a reference with the string, you actually need to make the string first and then pass it in. So that's a big difference between the out and the ref. When you make use of it actually inside the function, if you're using a reference, then you never have to assign it, or at least it's not required. You could have a series of if statements inside this body, and then you might determine that you might not need to assign it, which is exactly what we've got here. The only way we assign name is if this returns back true. If it doesn't return back true, then we simply don't assign it and move to here. This is a problem if the out variable. If it changes to an out, then we're going to get a compiler error because it doesn't return back a value. So we'd have to write something like this at the top, name equals something, and then potentially assign it here and then return back false. So with reference, you don't have to worry about the fact that you might not assign it in every single path of your code. And finally, the main difference is the fact that out parameters are still used by value and this is by reference. Reference will be slightly quicker since you'll get the memory address location being passed in instead of the value, so you won't have two copies of the same variable. The focus of this task is to create a function that calculates the area of a triangle. So we're going to ask the user for a width and a height and store them both, create a function to calculate the area. the function is going to calculate it using width times by height, taking that calculation and dividing the value by 2, call it in the main and print out the area of the triangle to the screen. So let's start with entering the width and the height. So we can say enter width colon and have int width equals convert to int 32 console.readline. And if we copy these down, change width to height and change width here to height. And just before we continue, because we did copy and paste down, then this is quite bad and we should use a function here. So in both the cases, we're going to output something to the console and then read it in and convert it back as an integer. So we can say static int, because we return back an integer so we can store it, we can say read int. And we want a string message so we can pass in this value inside here. So we take these two lines and place it inside here. Instead of enter height, we're now going to have message. Instead of int height, we're just going to have a return value, and then we're returning the conversion from the console read line. And now we can use it inside here, read int, and inside the brackets you want to put the string output, which is going to be enter height. If we paste that inside here, and then do the same thing for the previous section, and change height to width, and now get rid of these, so we just have these two lines. Perfect. So let's just print these out to the screen on separate lines, just to make sure it's working. Say the width of 10 and height of 15, we get 10 and 15, perfect. Since that's working okay, we can now create a function that can calculate the area for us. So we can get static int calc area, and we can have int width and int height. And then taking this formula, we can simply just do return bracket width times by height divided by 2. As you can see, this is literally exactly the same as what we've got here. It's crucial to include the brackets because we want to do this calculation first, take the value of that and divide it by 2. If this is too many steps, you can actually break it down. We can say int calculation is equal to the width times by the height, and then we can simply return calculation divided by 2 back to the function. It's slightly grayed out because we haven't used it, but that's not a problem, we're going to use it now. I personally just prefer is to keep that inside here and just have the brackets since it's a bit more obvious to me what's going on, but it's up to you as the programmer. Either way, it makes no difference, it's just more for the programmer's convenience. So now we need to call the function above, so we can say int result equals calc area and then pass in the width and pass in the height. And then we can have a console write line that just says the area is and then result. And then let's run it. So you have 10 and 15 and there we go, we get the area is 75. Perfect. If you didn't want to call the function inside here and store it inside a variable, you could just output this straight to the screen by placing the function call straight in the curly braces, and if you run that again just to make sure, 10, 15, and we get 75 again. Perfect. So just a quick little recap, we had the console write plus the convert inside this function, which will let us return us back an integer, and we can pass in the message straight in the variable. To make this a little bit quicker and a bit easier, you can actually just change this one word inside here. So you could actually say enter message colon space, and then just inside here, you can say height, and just inside this one, you can say width just to reduce on code. Because in this specific case, the only thing that changes between them two string variables was the fact that one was width and one was height. There we go, you can see it's exactly the same now. So after we've read in these two variables, we pass it into the function, and all the function will do is take width and height, times them both together, take that value and divide it by 2, and return it back to the user. And then we can call it straight in here, the area is calc area, and pass in width and height. In this task, we're going to create a function that will return us back with the sum of numbers inside an integer array. So first step is to create and initialize an array of numbers, create the function with the int return type, and it also takes an int array as a parameter. The function should return a total of all the numbers inside the int array, call it in the main, output the total. And just for extra bonus points, inside the function, instead of using a for loop immediately, you can check if the array length is greater than 0, and then return -1 if it's empty, and then check that inside the main and then output a specific message, and also see if you can think of any other implementations you can use instead of having to do return -1, how else can you make this function? Whether that means you have to change the parameters or return type or anything like that, just have a think about the situation and see what other options you can make. Of course, the output at the end is still going to be the same, but it's the way you do it and the problem solving skills that I'm trying to get you to get used to. Let's get started. So let's create and initialize an array of numbers. So we have int numbers equals new int, and let's just allocate them manually 1, 2, 3, 4, 5, and add a semicolon. There we go. Now let's create the function sum of numbers, and we want it to return an integer back with the total, and we want to take an int array called numbers. And then inside here, we need to actually return back an int, so we can create an int total, make that equal to 0. And at the end, we can return total, and then during the middle, we're going to have to write our for loop so we can go through the integer array and count through everything. So we can use a for each, var item inside our numbers, and just inside here, we can say total plus equals item. Perfect. So if we can call it in here, we can have a console write line, and we can just say sum of numbers and pass our numbers array in the parameters. So we're just going to output it to the screen just for the time being. So sum of values from 0 all the way till 5 is 15. Perfect. So now that we've done that, we've created a function that returns the total numbers, call it in the main, output the total. So we can just say the total is, and then wrap this round in the curly brace. There we go, the total is 15. Now as the extra points, we can check the array length and return -1 if the array is empty. So let's see what we can do in here. Before we even end up going inside anything to do with the total, we can wrap this around in an if statement that says if the numbers.length is greater than 0, then we can proceed with this little section. So if you highlight all of this, hold Alt and press up arrow key, then because it's one back, just press tab once, and just press the delete key here, and let's get rid of the empty line. This is going to return us back with an error because not all code paths return a value. If this returns back true, then we'll eventually hit a return, but if this returns back false, then we'll not do anything inside here. So let's have a look at our requirements. Return -1 if the array is empty. This dictates whether the array is empty, so if this returns back false, then it's going to come into here, and we can say return -1. So we've got this function call in here. We don't want to print the total right now, because we want to make sure that this total is actually greater than 0, because we don't want to make a sum of the numbers if the array is empty. So if we run this right now, we're going to get the total is 15, and if we get rid of all these variables and just have the length of 5, but not give it any values, so all the values are going to be 0, then if we still run that, then the total is going to be 0, but that's still an acceptable value, because that's actually got values inside. But if you said the array length is 0, then the total is -1. Of course, we don't want the user to see -1, so we want to bring this back, and instead of calling the function immediately down here, let's call it here. We can say int result is equal to this. And then we can say if the result is greater than -1, then we can output the total. And again, press into this line, hold Alt and press arrow key, and then we can place the result inside here. And the else to this will be cannot add up an empty array. There we go. So now if you run it, we should still see 15, but if we get rid of this and put it back to 0, there we go, we cannot add an empty array. So if we bring that back, perfect. So now if we check this, we've got check in the main, output the message, and then now we've got this little solution. Do we need to return -1? How else can we make this? So right now we're going to have to return back -1 because that's the only way that we can tell the user whether or not it's been successful. If the array is empty, we return -1, and if the array is not empty, then we return something greater than -1, which will be something above 0, or 0 itself, but as long as it's greater than -1, that's how we know it's complete. But we don't actually want to do this. We want to be ideally returning back a boolean. So let's duplicate this function and show you both implementations. Let's change this into a bool. And then because we're still going to need to reference the total, we're going to have an out int total. So we need to change up a few things inside here. Instead of this return -1, we can do return false to indicate that it hasn't been successful. Instead of returning back total, we can actually just return back true. Now we haven't done everything yet. We don't need to redeclare int total inside here because we already declared it inside here. So we could just initialize total to equal to 0. But the problem here is, if we make total equal to 0 just within this path, then it's still going to complain that total must be assigned. So we can take this and just assign it right at the start of the function, just like that. There we go. So we make total equal to 0, that gets rid of the compiler errors and gives it a value. The reason why we have to give it a value is because this out int parameter doesn't like it if you don't assign the value. That is a requirement for using the out parameter. So we make total equal to 0, check the numbers length. If this were to return back false, then we return false to indicate that we can't do anything. If this returns back true, it will go through and count all of the items, place it inside total, and then return back true. So let's have a look and see what else we can write this little section of code. So instead of having to call it inside here and use it within there, then we can actually do this another way. The reason why we're actually calling this straight inside here is because we can't place this straight into here since it returns us back with an integer. And now that is actually fine if that returns back with integer, because as you can see, there's no problems here. The issue arises is when we have our result variable, we can use it inside the bracket and down here. There's no point in calling this twice to get the same value, although this would still technically work, but this is not really efficient since you're calling the function twice. It's best to call it once, store the value, and then make use of it twice. When we use our out parameter, you'll see that this gets a bit easier. So straight inside the if statement, we can say sum of numbers, and then we can pass in our numbers, and then space out int total. And what that'll do now is, because this returns us back with a bool, we don't need any additional conditions like we have one here, because this will turn us back with a true or false. True if it succeeds, false if it doesn't. So we don't need to say if it's greater than -1, because we don't actually care about the value of the total right now, we just care if this returns back with true or false. So inside here we can take this same output message, and instead of having result here, we can have total. And then we can take this exact else statement and place it here, and let's see what happens now. The total is 15 and the total is 15. So they're both returning back the same values. Let's add something else on here just to make sure it works. There we go. So you can see that both these solutions look very identical, but one is considerably different. We have to make a variable outside, use it inside here, and use it inside here, whereas in this function, we can actually just call the function straight inside. That will process our new out int total, and then we can simply use total inside here. And we don't have to require another additional variable just outside here, as this one will. And you can see that the functions is a little bit better, because we're returning true and returning false to indicate whether or not it's been successful, whereas in this solution we have to return back an arbitrary value and then check that in the console. The reason with returning -1 is kind of a problem is, what if these numbers are actually all negative? Then this value is going to be very bad. This can only really work if all of these values are positive. If you had negatives for all of these, and we tried running the code, there you go. This is a major issue. Cannot add up an empty array. Well, it's not the fact that it is empty, it's the fact that these values are smaller than -1, so you don't actually want to be going with something like this approach, where you're comparing the value because you don't know what numbers are going to be typed into here. If the user were to type in positive or negative, you want to provide a solution just like this one that works for either positive or negative. You don't want to restrict that. By checking if it's greater than -1, only works if all of these are positive values, or this is an index for the array. Since arrays start at 0 and go upwards, you can't have a -1 array position. But in terms of numbers that are randomly typed inside of array, you should always be wary of using this option, because if some of them are negative, then this could return back false. So let's just have a quick recap. So we have an integer array, we have our values initialized down here, and then in the first solution we call the function, pass in the numbers array, get our result back, check if it's greater than -1, then that means it's been successful, so we print it out, and else we tell it it's an empty array. Now second option, we actually call the function because it returns back a boolean in this case, so we can place it straight inside the if statement, and then we can pass in the numbers array, and then we have an out in total, which will give us the total, and in this case we don't need to check the value because this returns us back with a true or false, and in this case, true determines whether it's been successful and false it doesn't. If it returns back true, then it has some values inside the numbers array that we can actually add up, and if it returns back false, then that means the array is empty. So let's have a look at the implementations. So without the out parameters, this is the first solution up here. We get the number's length, check if it's greater than 0. If it's not, we return -1. Make a new variable called total, make it equal to 0, and we run a for each loop, var item inside the numbers, and we just say total plus equals item, add them all up in the for loop, and simply return the total. And then in the out solution, we have a total equals 0, which just initializes this variable, otherwise we'll get a compiler error. Then we can say if the numbers is greater than 0, then we can say if numbers.length is greater than 0, then we can do the for loop and return back true. And if return back false, then we can say false inside here. And then when we use it straight in the brackets, we have access to it straight away, since it uses a boolean variable. And then our value will be placed inside our out int total parameter, which is used down here for the output to the screen. And again, if this returns back false, then it'll say cannot add up an empty array, and then we hit the console read line and wait at the end. There we go, that covers everything inside here. Exceptions are used to prevent your code from crashing and then the program closes down. Let's have a look at a very common example. let's have a console write, and we can say enter a number. And then we can use int num equals convert to int32, and then we can have a console.readline inside here. And let's just print out num to the screen. Now if you assume everything goes well and we actually enter an integer like 15 and we press enter, then we simply get 15 returned. And as we saw in the past when we covered the try parse function, if you enter anything else that's not exactly a number, then you're going to get an exception. Exception unhandled. Unhandled means that we haven't wrote anything specific that will handle this exception, so it's causing the program to close. It's a system.format exception, and it says the input string was not in a correct format. So this is a format exception because we've entered in a very weird set of characters that can't be converted over to an integer. So now our program is forced to crash, and now the rest of our code is going to be deleted now because it won't be able to run. So if you had any important data that was stored just before this point, then it is now lost. This is very crucial because if you have a system that writes to a database or it stores some very important information that someone's typed in, you want to handle the exceptions so if something were to arise, it doesn't actually close the program down and they lose all of their data. I'm sure you've had it in the past where you've tried to do something and the program comes up in Windows and it says this program had stopped responding. When that normally comes up, it means that something's happened that's so fatal that the program cannot continue, it has to crash down, and in most cases this is what's called an exception. So if we run this code again, let's have a look and see what else we can do to make this code break. So of course, as we've said before, a num integer can only survive up to about 2 billion numbers. So if you enter a number bigger than that, let's see what happens, then we get an overflow exception. A value is either too large or too small for an int32. Of course this number is very big, and only a long would handle something like this, and an integer definitely won't. So these are the kind of exceptions where you'd have to handle it yourself manually, otherwise your program's going to crash. Coming up next, we're going to go through the ways that we can handle these and make sure our programs don't come to a halt exactly like these examples. I want to explore a technique called try-catch. This is very similar to when we use the int.tryParse. What this essentially does is it tries to do something and it lets you know if something went wrong. This is exactly the same when we're dealing with exceptions, except when we're doing a try-catch, what the catch means is it's catching the exceptions that happen, and therefore it is now a handled exception instead of an unhandled exception. So before we try and fix how this works, let's just explore the syntax. So we can type in try, followed by curly brace, and just after this curly brace, we can say catch, and then we're going to put something inside the brackets, and then we have an opens brackets. If you wanted a quick shortcut to this, just like we've done the for loop and we double tap tab, we can actually delete this. So you can type in try and press tab twice, and then you get try, the open brackets, you get the exception, and then we get a throw. So let's get rid of this. And what we can do right now is we can actually place the code that we want inside here, inside this try bit. Because we're telling the compiler that we want to try to do the things inside here, and then we want to catch these things. So inside these brackets, what you want to actually do is decide what thing that you want to catch. If you type in exception, this will catch every single exception. Now the problem with that is you'll actually face some difficulties when you're trying to output very specific messages. So as we've said before, when you type in a value too large, you get an overflow exception, but when you type a value that can't be converted like a square bracket, then you get an input format exception. So first what you actually want to do is run this code outside the try, and let's run it now. And let's get them bad values. So we had the square brackets and we can get this, and let's copy it down and place it inside a comment, just like this, and then let's rerun it. And if we type a number too big, take this, stop the program, and put it inside here. So now that you know what the exceptions are called, we can actually write these inside the code. So we have a format exception and an overflow exception. But before we get into these specific exceptions, let's just catch everything. This is just to catch all, and then see how this works. So as we've put it back inside here, let's see what actually happens. So we can just put a console write line here and say, something has went wrong. The reason why it's something has went wrong is because this is a catch all. Any exception appears during this code, it will always come into here, regardless of what the exception is, whether it's a format or an overflow, it doesn't matter, it will always come into here. So it's going to be something because this is not specific at all. So let's run the code, enter a very big number, something has went wrong. But if you notice how the program doesn't actually crash, it's still very much alive. And we can test this by putting a simple message here at the end that says goodbye, and we run it again, enter a big number, and there you go, we get the message as goodbye. So it successfully skipped over this section without actually causing an exception that breaks the program. So even though we've entered something very fatal, because we've handled it, then there's no problems. So if we now type the other one where we have the square brackets, then you'll see we'll also get something has went wrong. So if we wanted to catch a very specific exception, what we can do is say catch, open the brackets, and we can say format exception, just like it says above here, and then place the curly braces. And what you can do now is you can actually chain these, and these go from top to bottom. When an exception occurs up here, it will match this one. If it doesn't match, it will match this one. And you want to put the catch all right at the end, so if it doesn't match any of the ones above it, it will always match the last one. So you can have a generic message inside here, but you can have a very specific message inside here. Because it's a format exception, you can say please only enter numbers. So now if we run the code, and if we type in square brackets, it'll say please only enter numbers. There we go. So this is a very specific example. And if we copy and paste this down again, and then we can say overflow exception, and we can say please enter a number less than 2 billion. If you enter a very big number again, please enter a number that's less than 2 billion. Perfect. So this will get checked like if statements. It will start on the first one and go down the list. Imagine this is an if, and then we have an else if, and then an else if as well. If you place this one right at the start, then you're actually going to get compiler errors, and you can't actually have the catch all right at the start. So even if you wanted to, the compiler literally doesn't let you. And anyway, you don't really want to be doing that, because then you'll be ruling out these two, and it's kind of pointless writing this code if it's never going to get used anyway. So now when we run the code, you can see even if we type in a bad value, our program will still run and everything works okay. So now what we can do is actually make this into a real life situation. So if we actually type in 10.2, and it says please only enter numbers, then we're going to have an issue here, because if we try and print the value down here, then it's going to cause a problem. Let's try and print out num, and you can see that num does not exist. Now we have an issue of scope. Int is only declared within here and here, so if we wanted to print out the value of num, we'd have to print it out up here. So now let's run it again, and if we enter 20, 20 comes up. If we enter 15.5, then it actually skips over this console write line, because the exception occurs right here, and then it'll jump into one of these paths. So in order to store the value of num, you can either move num outside here and make it equal to 0, and then assign num inside here, and then you can take this console write line and actually put it right after the try parse, but I don't really suggest this option. So if you said 15.5, then you're just going to get 0 returned, but we don't really care about the 0 because we're not going to get the value converted, so why do we need to print the 0? And the answer is we don't. So what we should do is keep it all inside here again. And then what we should do instead is wrap this around in a while loop. So this will try to do the code, this section will catch them all, and then we simply have a goodbye at the end. But let's just make sure that this actually runs, because if we type in 15.5, then the user still hasn't entered the number, but our program is closed. So we want to loop around until the user has successfully entered a correct number. So we can say bool looping equals true. And we can have while the code is looping, then we can have the curly braces. And let's place our entire try catch inside here. If we highlight it all, hold Alt and press the up arrow key, and then tab it once, and then get rid of this empty line. So now we'll keep looping around here until this is going to be a different value. So because the while loop will only keep looping until this is true, and the moment when it's false is when it'll cancel the while loop. So as I said before, when we run this code, and then just at this specific line, if the exception occurs, it will actually skip this line and jump below here. So if it skipped this line, then what we can actually do is we know if it reaches this line, then the conversion's been successful. So we can print it out to the screen and we can say looping equals false. And we don't need to place looping is equal to true inside all of these three paths, because if we don't assign it to true, then it's still going to be the value of false no matter how many times you loop around. So let's try and run that now. Enter a number 15.5, enter a number 15, and we can keep doing this forever as it's a while loop, and as soon as we enter a valid character, 20, and now it says goodbye because we hit the end of the program. So that's it for this video, but let's just have a little recap. So we've determined when we ran our code, just these two lines, that in both situations we can have a format exception and an overflow exception. We can use these to catch them specific exceptions and then have a catch-all at the end. The reason why you want to catch multiple is you can have a very specific message. Overflow dictates we have a number that's too big or too small to fit inside of an integer. It can be less than -2 billion or it can be greater than 2 billion, and that's how you get the overflow exception. We get a format exception if you entered something that's literally not a number or something that has decimal places, and then our catch-all can be if anything else goes wrong, we can output a generic message, but in 99% of the cases, you'll either enter a number too big or too small, or it's in the wrong format, and this exception is just so it catches everything else should anything else happen. So at this point, even though our program doesn't actually close and there's no exceptions, the user hasn't had a chance to enter the number again. So we use this inside a while loop, and we can say while looping is true. When we hit a conversion that's successful, we say looping is equal to false, and once it hits this line, the while loop will then exit, and then we'll get our goodbye message. And we wrap the entire try catch inside the while loop, just so this keeps on looping until the user has typed in a successful value. As demonstrated above, we can type all this, and 15.2, 15.15, and then finally says 15, and then goodbye. So I want to explore different ways you can output messages inside this catch block. When you have a catch exception, this is actually a parameter that we're passing in. This parameter can actually have a variable as well. Normally when you specify parameters in a function form, you say int and then something. Whereas right now we're kind of defining the data type, which is our exception, in the same case as int in here, but we're actually not giving it a name, so it looks something like this. Of course, when we do this inside a function, we're going to get a syntax error. But for a catch, we're not going to get any errors at all. And the reason is because we can catch without having to use a local variable. So if we actually add a local variable, make you call it e for exception, then we actually have lots of options inside here. Type e, then we have lots of data, and the stack trace is very helpful when you're debugging, but we'll cover that at a later date. The thing I want to focus on right now is the message. So we can use this and print it out to the screen. So we can say error, and then type in e.message, and let's run that. Now if you enter something invalid, input string was not in a correct format. If you enter a very big number, then value is either too large or too small for an int32. As you can see, these error messages are pretty descriptive, and normal users should be able to read this and understand it. Of course, if you want this error message to be more specific, then you can add some more catches inside here, and we can have format exception. This will be if you type in something other than number, but if you do exactly the same thing in here, then it's kind of redundant because you're just outputting exactly the same value. If we try put the square brackets again, then we're going to get this string, which is actually outputted from this line, but even if we include the catch-all exception, you get exactly the same error message outputted from here. The moral of this story is, you should always have a catch-all right at the end of your chain. But if the only thing you're going to do inside here is simply output this message to the screen, then you don't need any multiple catches. What you should do is catch multiple exceptions that you know are going to get fired in your code, and then you want to handle them, and then have a catch-all at the bottom that will display the message generically. Instead of displaying the message right here, you can actually have a more specific message like we covered in the last video. So this could be, please only enter numbers, and we don't actually need the message in this case because we know what exception we're going to catch because we've specified format exception. Another little tip, if you hover over the function call, it says here, format exception and overflow exception, which is the two that we handled in the previous video. This is very easy and understandable if you can just read the values from here and to see what exceptions can get raised. And the same thing here, you get an IO exception for the console write line. The console write can also give back an IO exception as well. Generally speaking, these console functions almost never return back exceptions. I don't think I've ever hit a situation where this exception has been returned, unless you do something ridiculous and maybe you type in way too many values that the console write line can handle. Let's try an example and we can do something like this. If you enter a very big number that can't be specified inside an integer, then console write line has so many overloads that it actually processes it as a long right now. So you almost can't break this unless something fundamental to your computer actually happens. So you have exception E, and with exception E, you can actually take this local variable and print out the message. This is the preferred pattern because instead of outputting here something went wrong just very generically, you can actually give them the error message that comes back from the exception. The reason why this is helpful is because if it doesn't hit any of these exceptions and it just happens to fall into the catch-all, at least the user has an idea of what the error message is going to be. The preferred option is to try get to a point where you never have to reach the catch-all and try chain as many catches as you can in order to handle as many exceptions based on the code that you're writing, which can be found if you hover over the function and read the exceptions. Once you've covered as many options as you can throughout the catches, then you almost never have to worry about the code entering this section. Because we've covered both the exceptions in format and overflow, and we can do the overflow right now, please enter a value under 2 billion, then that means we've actually covered all of the catches that are to do with converting an integer 32, covered format and covered overflow. So when we run this code, the only two things that can possibly go wrong are these two functions, the format exception, overflow exception, and we won't ever hit the catch all in this case, but if anything goes wrong, at least we have a belt and braces option to catch it and we can tell the user what happened. And because it's e.message, then the value is going to be quite descriptive so the user can read it without any problems. So in this task, we want to be able to convert a string to an int successfully without any errors occurring and without any exceptions that could break our code. So in steps, we want to create an int and try and convert any string from the console to an integer. Notice the error that appears when you try to do that. Write a try catch handler around it to successfully operate that and output the message to the screen. And you won't need to change the console outprint and the convert int32 to be able to make this work, so you don't want to change the current code, you just want to add the try catch handler around it. So why is this a bad situation? How can we know if it's been converted? This is just a question that you should keep at the back of your head, and we'll answer this shortly. And then finally, we want to create a custom try-parse function, find the real try-parse function and copy the return type and parameters and see if you can mimic its behavior. Read the tooltip it gives you to give you ideas on what to do. So let's take these in steps. First, we can have a console write and say enter a number, and then int num equals convert to int32, and then we need a console read line. And then if we run the code, if we try and just convert some square brackets, then we get a format exception. So that's the exception that we're going to be handling right now. So we can take this code and we can wrap it around in a try, use Alt and up arrow key, and then just after do a catch, and then we want to do a format exception, and then space E to give it a variable, and then we do e.message out to the screen, and now let's run the code. Square brackets, input string was not in a correct format. So we get our message and our exception has been successfully handled and our program hasn't crashed. But the problem is it's got to this console read line and the user hasn't had a chance to actually enter a number. So what we can do in here to ensure the user always has access to writing a number is we can say something like this. Bool success equals false. And then just after here we can say success equals the true. And then just down here we can say console write line, success, question mark, yay, and then colon or no. So if it converts it at 15, we should get a yay. And if we convert it and it fails, then we should get an or no along with the message. Of course, what you can also do is wrap this entire section inside a while loop, but we've already covered that inside the tutorial, and that means it'll keep repeating this until this is set to true, and therefore exit the while loop, and then the user's finally typed in a number. So let's go back. So we've noticed an error and we've wrote a try catch handler around it. Now we want to catch the error and output the error message, which we've done, and then we haven't changed the current code, which was these two lines. We've added a boolean and set it to true here, just so we can have a bit of an output message before. So why is this a bad situation? How can we know if it's been converted? So this code is a bad situation because we just have these two lines outputted, and then now that we've added our boolean to tell the user whether it's been successful or not, is actually making it a bit more meaningful. The problem is, even if we print or no, then the user doesn't really have a chance to enter it again. So like I said before, you could loop around and use a while loop to make sure that this situation can go from something that gets handled into a situation where the user can actually type it in. There's no point handling an exception and realizing there's an error if you don't give the user a chance to enter another value. If they enter out 15 followed by a full stop when they only meant to type 15, then you need to give them another chance to type in that 15 value, otherwise the program is simply just going to end and nothing's going to happen. For example, 15 dot, it says oh no, or you can have another message that says something went wrong, or you can have a more specific message about the conversion, and then once you press enter, the program simply closes. This is not an interaction that you want the user to be able to reselect another value. So that's why it's a bad situation, because you know it's being converted or not using our bool success, but the problem is we don't have any sort of looping. So let's have a look. So now let's comment out this, and let's see how we can make our custom try parse. So you type in int.tryparse, you can see they have a bool, int tryparse, string s, and out int result. So let's try and copy that and make our own custom function. So we can say static bool, and then it's tryparse, and then we have a string, input, and out int result. Perfect. So now we can get rid of this line just so we use it for reference, and let's use it straight in here, and then we can write the implementation in a second. So we can say if tryparse, the thing that we want to parse is actually a console read line, and then we just say out int result. And the console read line is going to be answer to this question, which is enter a number. We place that straight inside here, and then we say out int result. So if this has been successful, we can print out yay again, and else. If it's not successful, we can print out or no. Of course, you can do other things inside here, or you can even print out the value straight from here. So we can say yay plus a space, and then result, just so we can get that back to the user, and then or no if something goes wrong. Of course, this is just so we can test things and see how they work. So this tryparse function, it will take in a string input, and it will try and give us back the result. So in order to be able to make this successful function, what we need to do is essentially do the conversion ourselves, which will be this convert to int32. So first we need to assign this out int, so we can say result equals -1. So now that we've used that, we actually need to have a return type as well, but let's worry about that in a second. So essentially what we actually want to do is say that the result is equal to convert to int32, and then we want to convert the input, store it inside the result, and if this goes successful, then we want to return true, and if it doesn't go successful, then we want to return false. But of course, we need to be able to do these things separately. So like we said with the try, you only wrap around the section of which is going to be problematic. So in this case, as we've done here, we've wrapped the convert int32 inside the try, so we're going to need to do that down here as well. So we can open the try right here and place these two lines inside, and then have a catch. Have a little think about what sort of catch do we need. The whole point of this function is to simply convert value and return back whether it's been successful or not. There is no messages here, we just need has it been successful, yes or no. And because we only need to know if it's a yes or a no, then we can just have a generic exception, and we don't need the e variable because we're not going to access the message. We're going to keep it as an exception. And instead of returning false down here, we actually want to do this straight inside the catch. So now the code reads like this. We set the result to -1, and the reason why we do that is because if we don't, then we're going to get a compiler error, and it says that not all paths we're going to assign result. Alternatively, we can also assign result straight inside here, just so we have an assignment in both paths, or you could just leave it outside at the top. So we assign result to -1, and then we place our problematic code straight inside here. We try and convert the result, and if this line returns back successful, then it's going to execute the second line and return back true. If this line returns back an exception, it's going to miss this line completely and jump straight into the exception and then return us back with false. So let's actually try this and see what happens. 15 dot, or no, and then 15, yay 15. So the reason why we don't care about the exception in here, we can add in different values as we've used before with format exception, overflow exception, but as we saw with tryparse, it simply just returns us back with a bool. The bool simply tells us if it's been successful or not. So we could stack these multiple times. We can say catch, and then we have the format exception, and then we can place a return false in there, and then we have another catch for the overflow exception, and we can place another return false in there. But as you can see, we're just returning false inside here. So now that we've changed these, it's kind of pointless. Each of them are returning back false, and because we're not doing anything very specific, we don't actually need to chain them all together. We don't care about the message, we don't care about the exception, we only care about the fact that something has went wrong, and if something has went wrong, then we return back false. If everything goes okay, then we return back true, and that's all this try-parse function is going to need to do. It simply converts it, or it doesn't convert it, using an input and outputting a result. So if we run it, we type in a real number, we get a number back, and then 15.0, then we get oh no because it can't convert it. There we go, we've met all our requirements for this program. Let's have a look at how we can do debugging using Visual Studio to step through our code manually. So this is the example I used last time, int age equals 35, And ideally in this case, you'd want something like 30 plus to be printed instead of 18 plus. Even though 18 plus is still technically true, we'd still like 30 to be printed in this case, because this says if it's over 18, do 18, if it's over 30, do 30 plus. So in order to start the debugging process, you shouldn't run the code first. If you run the code first, it's going to execute so fast that you won't get a chance to actually put any code in and try and debug it. There we go, we've already hit the console read line and it's executed for a split second. So the best thing to do, just to the left of the line numbers, you want to press in the gap, and that'll create a red dot, and it'll tell you that this is a debugging red dot just in this little tooltip, debugging.program.main. Debugging program.main. So it tells us that we're in the program class and we're going inside the main. You can also address the debug menu up here, and it says we can have a toggle breakpoint, we can add new one, we can delete them all, or we can actually disable. Deleting them will just simply get rid of them. As you can see here, if I set a couple more and press disable, then it's going to hide them, so when I run our code, it doesn't actually apply the debugging, but it doesn't delete them, and then we can enable them, and then we can also delete them all. And it gives you a little prompt, because if you're doing this inside a big project, and you just spent a lot of time going through and debugging certain functions, then you don't want to be able to delete them all without any confirmation. So let's delete them all and put it back on line 13, which is our int age. So let's run the code and see what happens. So as you can see, it minimizes our console for us, and nothing's actually been printed yet because we're only up to this line. And then we can use these buttons up here. Step into goes inside a function. Step over goes over the line, so it'll go from this line to this line. Step out is used after you've stepped in. If you stepped into a function and then you don't want to see the rest of the function executing, you can step out to jump back out of it, which I'll demonstrate later on in this video. So now that we've hit this line, you can actually see what's going on. So we have int age equals 0, because when this line is highlighted, it means this line hasn't executed just yet. So we can press this, or we can press F10 on our keyboard. If I press F10, you can now see int age has the value 35. And what you can actually do is double click on it and just change the value to 30, for example. Now if you highlight, you can see the value is 30. So you need to double click, change the value to something, and then simply press enter. If you change the value, but leave the box like this, then it won't change the value. So you have to remember to press enter. So now I've made the age 40, but let's just change it back to 35 to keep it the same. And then now what we can do, we can explore what's going on here. If age is greater than 18, then we're going to check if this condition is true or false. So in order to check if this returns back true or false, you can actually hover over the operator, and it says here, age is greater than 18 is equal to true. And if we hover over this one, it says age is greater than 30 is equal to true. Notice what we actually did there. We essentially ran this condition through the debugger without actually reaching this line. We're only up to line 15 as of right now, but we've managed to execute this and give us back a function. So as you can see, age greater than 30 is true, and age greater than 18 is true. And because this is an else if chain, it only cares about the first one that turns back true. And because this one has turned back true, then if you press F10 again, you'll see that now it's went inside this curly brace, which will print out the console write line. And if I press F10 again, you can see we're now waiting on here. If I use Alt Tab, I can get back to the console. You see that 18 plus has now been printed. Now that we're waiting here, we actually press F10 one more time, and then it jumps straight to this read line. Of course, because this is an else if chain, as soon as one of these become true, it jumps over the else if, because of course this is a chain. The first one it hits that's true, it skips over the rest. If we didn't want this to be a chain, then we could keep them as both independent if statements, if age is greater than 18, and if age is greater than 30, and don't use the else keyword. But in this case, because you do want to output a different message for every single age range, you do want to place the else word in there. And now that we've hit this line, we can press F10. And then now we jump back in the console, and now we're waiting right here. And just a little tip when it comes to debugging, if at any point you just want to exit the debugging, you can either press continue or just press F5 and the program will run. For example, if we investigate this variable and we can see the value is 35, and then now we're happy with the rest of the code, we can just press F5 and our code will run as normal. We'll get the outprint and we'll get a read line waiting here. So we know our problem here is both conditions return back true, so just like in the last video, we actually changed this condition so to make sure that it only goes between this range. But let's not repeat ourselves, let's have a look at a different example. So we can have string name equals ABBA, and then int age, and then age equals 23, which I'll demonstrate why I've done it like this in a second. And then let's have a function just so I can show you how to step in. So we can have a static string, print details, string name, int age. And here actually we want to just return back a void because we just want to print it out to the screen. And we can say name, space, age. And maybe just put a dash between them. And let's run that code. Now we can see ABBA-23. Of course, making that function wasn't the point. I actually want to show you what's going on. So if we just print this a couple of times just so we can show you the step out and step in. So if we run the code now, we can see our string name. If we go over that, you can see it's called ABBA. And then now that it's stepped over this line, because there's nothing really to execute here, it's just creating back a variable. So you can see the age is 0 because that's the default value for an integer. And when we skip over that, now it's got the value of 23. So one line creates the integer with the default value equal to 0, and then the next line will make it equal to 23. And then we're passing in the variables here, and if you wanted to investigate it, you could simply just hover over them like this, so you can see what the values contain. And then now that we've hit this function, if we press F10, then it's just going to skip over it. But what we actually want to do is be able to go inside the function. So this is where our step in goes. Step over doesn't care if it's a function or a normal line, it'll just step over it regardless. So we want to, in here, we want to use step into, or we can press F11. Once you press F11, you can see that now it's jumped from print details up here to print details down here. And then now look, if I step through, it's going to actually execute these one by one. So right now it hasn't executed anything. So I step over this once using F10, you'll see it now appears. And then the same thing with this one and this one. And now that I've executed 3, we should see 3 in the console. Perfect. So now what I want to demonstrate is, let's say we're happy with the rest of this function. And then now we want to just step out. So I press this button and you can see it jumps back up to print details, F11 to go in, and then shift F11 to go out. So now that we're back in here, the only thing we can do really from this point is either press F5 to stop debugging or press F10 to jump to this line. And at this point, we've already hit the last line now code. So we don't really need to use F10 anymore because we've nothing to step over. So we could just press F5 and let our program finish. And there we go. So let's have a look at another example. We can have a string message equals read from console. Then we can pass this in, enter anything. And then we can have a console write line and we can just print the message. And then let's create this function. So because it's a return value and store it inside a string, we're going to need a static string, read from console. And then this is one string parameter. So we'll have a string message. And then we can just do a console write. And then print the message to the screen. And then we just want to return the console.readline. There we go. And again, let's put a breakpoint here. And we can remove this one so it doesn't always have to be the first line. If we're perfectly happy with this amount of code, then we can simply take that off and it'll stop when it gets after this line. And now if you look at the console, you'll see all of this is executed. That function is executed 4 times to print the name and age of the screen, and now we're waiting here. So we have our read from console, and now we can step into using F11. And you can see that if you hover over the string message, it has enter anything, which is our parameter that we specified up here. And then there you go, and then that'll print it to the screen. So you tab back in, you'll see it says enter anything. And then just at the read line, we need to actually enter it now. Something. And then press enter, and then just right here, it's going to return it back. So if we use F10, it jumps back in here. And then actually we need to execute this line. So F10 again. And then if we hover over message, you see it says something, which is exactly what we typed in the console here. And then we just print it back to the screen. There you go. And now we're just at the console read line and we can press F5 to finish up. There we go. So debugging is mainly used by pressing this button on the side. So debugging is used by pressing on the empty gap just to the left of the line number and it'll create a red dot. Once you create a red dot, it'll highlight this for you. Once you've clicked on it, it should show up a red dot. You can also disable or delete all the breakpoints from the debug window at the top of the screen. When you run the code, it will stop here, and then you can either use F9 as a shortcut as well. Click into the line that you want to debug and press F9. Please note there is specific cases where if you try and press this one right here, it's not going to let you. If the line doesn't really do anything, for example, this is creating an integer. There's no real action that's happening here that you should or want to debug. This is an assignment, this is an assignment, this is a function call, and so on and so forth. And this is also a function call. When it comes to just declaring variables, then a compiler does not let you put in a breakpoint because there's nothing really to investigate when you're just creating a variable. So don't get thrown off or think something's wrong if you click on the empty line and nothing appears. So that's it for debugging, but let's just have a little recap. We can use F10 to step over, F11 to step into functions, Shift F11 to step out, or you can use the buttons that appear at the top of the screen when you run the code just right here. Hover over variables and you get their values. As I showed you in the if statements, if you hover over the operator inside the if statement, it will actually tell you what the condition is and whether it's true or false. So we can say if 1 equals to 1, and let's just print out true to the screen, just so I can demonstrate this. If I hover over the equals, it says 1 equals 1 is true. So that's how you check if a condition is going to be true or false when you're debugging. You can check the parameter values by simply hovering over it, and the tooltip should include the value, just like so. And if you wanted to step into this function, you can use step into, and then use step over, which is F10, just here. And then you can actually investigate these values as well, or you can look at the parameters, and once you're done with the function, you can do Shift F11, or you can use step out, and then you can skip over this, and the same thing with this. You can have a look at the string variable once it gets returned, something in here, and now it says something in here and string message, and then we can print out to the screen, etc. So you can have a little bit of freedom with what you can do in terms of debugging. Play around to debug it in the past exercises that we've made together, and then what you can actually do is gain experience in debugging, so when it comes to more complicated projects, you can also apply that learning there and make sure that your code is error-free. So we covered how to debug by pressing the white space just to the left of the line number. If we run the code, the program will stop where our breakpoint is and it won't execute the line that we're up to, we have to step over it. So we've actually used this before to analyze our functions and see what values are inside things. So we have these extra windows called the local and the auto. So let's take a look at them and see what they're about. So again, if you don't have this layout, you can use window, reset layout, and it should be on the left panel, not the right one this time. So we've got watch, which we'll explore later, and we're going to have locals and autos. So the autos, because we're up to the age, then it shows us the age has value 0, and then that prevents us from hovering over it, and if we step over it, you'll see that now it's got age 23, and now name has appeared. The auto tab will try and figure out what functions or what parameters you need to be displayed down here based on the section of code that you're currently up to. So my guess is because we're up to this function and it takes in a name and an age, then we're getting name and age appearing. Before when we were on this line, it was only showing back the age, and because that section only used the age, we only got age here. But if you press locals, you can see all the variables that are local to this main function are actually showing up. We have a parameter called args, and technically this is a parameter and it's a string array type, but it's currently unused, but it's still a parameter. So you can see it down here, and then in order we have the name variable down here, then we've got the age, and then we've got the message, which is currently set to null, because we haven't created this in memory yet. But as you can see, this changes depending on the scope of our variables. So now that we're about to hit this function, let's use the step into, and you'll see that the locals have now changed. We've got rid of name, age, arguments, and string message, and it's replaced with name and age. Because remember what I was saying about the scope of the variables? Parameters inside a function are always going to be local to that function around the curly braces that they're surrounded by. Name and age is only within here, so when it's trying to show us the local variables, it's only local to what's inside these curly braces, which in this case is name and age. So then if we step over this, and then if we step into this read from console, you'll see that just before we step into this function, that these have all came back, because again the scope has changed back to this function, which is our main function, which has all these variables inside. So our read from console will only have our string message, so hopefully when we press F11 or press the step into button at the top, we should only see the message variable inside here. There we go, we get enter anything, because that's what was passed in over here. And then as soon as we return back to that, let me type something in, and then we get all of the values again, and you can see that system.console.readline had returned hello, which is this line, and then if we press F10 again, you'll see that even though we've got it back here, our message is about to be assigned once we step over this. There you go, it says hello, and as you can see, this changes in real time, so as soon as we step over lines, hello got placed straight into there. This helps us tremendously because we don't have to keep hovering over variables like this to keep checking over their values. You can simply use this menu and it will always update, because whenever you change scopes between functions, that will automatically update, as you just saw in them examples. There we go, and then when the program ends, obviously this window is going to close down. So that's a very helpful method of being able to debug without having to hover over anything. In the next video, we're going to cover how to watch variables, and this can be very handy when you're looking for specific errors. Another really good debugging technique is the watch window. Let's press a breakpoint just left of line 13, and let's run the code and let's see what this is about. So we covered that we have the locals window and we have the auto window that will automatically give us the variables that we're currently in the scope of. But let's forget about that right now. Let's have a look at the watch window. It says here, add an item to watch. So there's a couple ways that we can do this. You can actually double click on a variable and right click, or you can just highlight it like this and then right click. And it says here, add watch, and you can press it. It says name, value null, because we haven't created it yet. So the default value is null as of right now, because it's not actually assigned anything. So if you press F10 and step over it, you'll see that it immediately changes to ABBA without us having to do anything except simply press F10, which is the shortcut for our step over button right at the top of the screen. This prevents us from having to hold over the variables to get the little tooltip so we can see the value. The power of this is we can watch variables and we don't have to worry about showing in the locals or the auto because it's always there. And if you have lots of variables like this, then you're only concerned about the one that you're watching. Locals and auto will always change depending on the scope that you're currently at, whereas watch will only do what you want it to do. So because we don't put age inside there, then it simply won't come up just because it likes it. If we check the locals, we have age in there, and the autos, we have age in there as well, but we don't have it in the watch. So what else you could do is actually just type straight into here, age 23. If you really wanted to, you can actually also type in conditions, age equals 23, that returns back true. So if you had an if statement that you wanted to track, then you could do that as well. So let's have a look. So if you had an if statement that said, if age is greater than 18, then we can just print out 18 plus to the screen. So let's run the code now and see what happens. So as you know, we have this condition right here. So if you actually highlight this and drag and drop it, you can see that the cursor changes and you can drop it inside here. Let's click on the age equals 23 and click delete. So of course we can't really render this function right now because we haven't even created the integer variable. So let's run over the integer variable, and as you can see here, it says age is 0, which is the default value for integer, and that is indeed 0 right now, and then age is greater than 18 is false. But as soon as I step over this line and it makes age the value of 23, you'll see that these two immediately change. You know they change because the values have went red. Red means that the values have just changed in the last button that you pressed. Whether that means you stepped into, over, or stepped out, it doesn't matter. Red always dictates that the values just changed. So now it's telling us that age is greater than 18 is returned back true. So when I step over this line, because this is returned back true, I should render 18 plus. Let's have a look, F10, F10, and there we go. We've reached the middle, which means that's going to get printed out now. So moving on to another example, we can have print details. If we go into this function, and let's say we're only concerned about the name, then we can print out the name down here. But as you can see, we already have it twice. So that's just going to update depending on the parameter name. And even if you wanted to show something like this, you can drag this down here and it actually shows you the output. This is very handy so you can see the output, because sometimes when you have it like this, it doesn't look very clear. You can also hover over it right there and you can see the value placed here. But again, it's very handy to have it here so you don't have to keep hovering over the tooltip just to see the values. And from here you can actually change the values. So we can just say Harry is now the value for the name. And Harry is going to be age 35. So when we press F5 and let the program run naturally, you'll see that Harry is age 35 now, and that's all done through the watch list down here, and it doesn't even matter because we have full control over the watch list variables and we can change their contents to see how our code acts in different situations. So please use this watch list as much as you can, and don't forget that once you can double click on variables and add it to the watch just from here. You can also say quick watch, and what that'll let you do is it'll give you the value, and then if you want to add it, you can press add watch here, or you can just keep pressing reevaluate once you've skipped over some lines. So let's say we skip over it now, and then go back onto it, and because it has a shortcut Shift F9, we can just quickly press it like this, and it says ABBA inside here. And we can change the expression, maybe do something like age, and then click reevaluate it, and it changes the value to 0. And then we can even change this to like 50, for example. And as you can see down here, it's changed to 50 as well. So you can drag and drop it into here, or you can double click and press add watch. It's up to you. Please make use of this watch variable and don't rely too much on the autos and the local, just so you can keep your own variables inside here, and you can have complicated outputs like these. You can check conditions, you can check console outputs, as well as just checking normal variables. So using the watch window, you have lots of different opportunities to keep track of your code. So we've got another debugging task. Let's try and run the code and see what happens. We're going to get printed over 18. So our value is age equals 35, and we're already getting over 18 printed to the screen. So if we place a break line inside here and actually run the code, we can see what's going on. We can add them inside the watch, just like this. We can add in all the conditions inside, just like this. Perfect. So we can actually see here that because our age is over 35, it's saying greater than 18 is true, greater than 30 is true, but greater than 50 isn't true, and we can easily see that. Except because this is an if and an else if chain, as soon as the first one is true, it's going to enter that one, and you press F10, then we get over 18. And then as soon as it finishes that path, it actually skips all the way to the end. The problem with this is we only want it to print over 30 since it's over 30. So we have to introduce ranges inside here, and we can say age is less than 30, and then you can have age is greater than 30 here, and then you can also insert an and say age is less than 50, and there we go. And now it says over 30. And if we change this to 55, then we should get over 50. And then finally, if we change this to something like 23, then we should also get over 18. Perfect. So what was going on here is because we had if and else if chains, then you're only going to get one of them printed. And because a value over 18 satisfied both the first path and the second path, then it's only going to print the first path. If we actually undo our changes all the way to the start, and then we actually flip the order of this. If we put our this one first and delete the else and change it to else if inside here, so now we have a new chain, except the first one in the chain is actually if age is greater than 30. Now if you run the code, you'll see that the first one actually says over 30. And it says over 30 and it doesn't say over 18 anymore, but it's simply because this is the first one in the list. As soon as it hits the first one, as I'll demonstrate now, it will go inside this bracket, hit this curly brace, and then jump straight to the end. You should always order them from smallest to biggest, because that will probably make the most logical sense when you're reviewing your code. And in doing so, you can actually have a more formatted code, but you need to watch out that the ranges need to make sense. If you have something like this, then you need to restrict this one because it's going to be blocking the second one. And you don't want to make these all ifs, because then you get multiple outputs. Now we should get 18 and 30 being printed to the screen. This is not something you want, so make sure that you place your ranges inside here by adding an and then placing the other end of it, which will be 30, and then this one will continue from it. So just to sum up, what you need to do is make sure that you use else ifs, and make sure that you have ranges, just so when one exits, it's going to check the other one and the other one. You don't want the first condition to beat the second one if that's for the right path. Age 35 goes into this path, or at least we want it to, but it's been restricted by the fact that age is greater than 18 when we had it like this. This is restricting everything over 18 to go inside this path. If this was even like 65, we should only fall into this one, and we run the code, then we're still going to get over 18. Which is still technically true, it is still over 18, but we have different outputs for this sort of age range. Make sure that you use else ifs and you keep in an appropriate range and keep them in the order of the if statement, going from lowest to highest, or whatever makes sense in that situation that you're using it. This is the start of object-oriented programming. Let's start with a concept called structures. Structures allow us to store different data types inside one data type, so it's almost like a group of data types. We can demonstrate this if you wanted to store something like a person. You would normally have something like a string name equals Abba and an int age equals 23. So in here we have a string name that represents their name and an int age which represents their age. And you can see that because these are two different data types, you can't wrap them around inside an array. You can't have a string array called person and then say we want to have two different values. Although this will still compile, we can't store both these data types inside our array unless you make the age and store it as a string, which will be 23 inside the quotation marks, and then you'll have to worry about converting it later on in your program. So this is not really ideal. So we have something called a structure. So just outside here, we can say struct, which stands for structure, and then we can have our name straight after. So we can say person. And the next line, we just open the curly braces, and let's see what we've just created. So now in order to make an instance of this, we can actually use that like a data type. So we can say person. There we go. So now we've created our person variable. Now you see we've got our own data type. Before we were just using string and ints and arrays and things like that, but now we actually have a new person. So because our person is made up of a name and an age, let's place that in here. String name, and then int age. Of course, you don't want to give them default values because like all variables, you don't know what the value is going to be to begin with. So now what we can do, person dot, and we don't actually have access to using these values yet. So what we're going to have to do, there is a concept called access modifiers, which we'll cover on later on in this course. But just for now, what this means is you either have private or public, and they're the main two words. There's other words that you can have, but they're the main two for now. If you have it private, it means you can't access it down here through person.name. But as soon as you make this public, then now it becomes accessible. There we go. We can make that equal to something. And if we take off public, then you see we don't have access to it. It's inaccessible due to its protection level because the protection level is private, which means that you can only access name within these two curly braces. The second you make it public, it means that anyone outside of the structure, e.g. down here, can also have access to name. So if we do that to our public on int age and string name, then we actually can access both now. We can say person.age and it comes up like this. The purple cube is a function and the blue is fields. You can actually filter them out by pressing them down here. Show only methods and show only fields. So we can do age equals 23 and I can actually just place ABBA inside here. And now that this data is essentially the same as this, the benefit that we have now is when we print to the screen, we can say person.name and then hyphen person.age. And if you run that now, then we get ABBA 23. If you actually copy and paste this line down and just remove person dot, just so we're using these two variables at the top of here, and we run the code, you should see exactly the same values coming up. There we go. But now what's really handy about this situation is we have two data types that are wrapped inside of one data type. Instead of having a name and an age, we have a person. Because what gets really easy now is if you wanted to add something else inside here, like for example, birth month, which for me is 5. So in here, you'd have to make another one, birth month equals 5. And then all we have to do inside our person is just say person.birthmonth, and we could just assign it right here. Instead of having to create a whole new variable, we add it up here, and then we can use it down here, and then we can add that into here, person.birthmonth. And we can add this to this one, and then get rid of birth month. And as you can see, it's exactly the same. So we've taken these data types and placed it inside our structure, so then we can just reference it by the person. This becomes very, very handy for this exact reason that I'm going to show you now. Let's say you wanted to read this data in from the user. So you have static, and then you're a bit stuck on what data type you want to return. If you forget about the birth month, then we have a name and age as a very basic person. But our return type only lets us have one type, so that's going to be a problem now. So you could do a string return that will give us back the name, and then we can say return person, and then inside the brackets, what you can actually do is do out int age. So you can have two output variables, an out age, and then a return string. So inside here, we could say enter your name, and then string name equals console.readline. If we copy and paste this down, and then we can say enter your age, and then we can say int age equals convert to int32, and then put the console read line inside there. There we go. Now that we've got that, we don't actually need int age because we've already got output parameter, so we just need to be age. And then after we've retrieved them two values, we can return name. There we go. So let's actually try that up here. So we can say new name is equal to return person and then out int new age. And I can take this exact line, paste it down here, get rid of the birth month, and then we can use new age in here and new name inside here. So let's run that now. Asks us what is your name, ABBA, what is your age, 23, and then we got ABBA 23, which is the same as what we've got before. But you see that this situation is pretty messy. We have to return a string variable and also use an output in order to be able to give back two values. Alternatively, what we could do is actually just return back void, and then we can say string name and then int age. But we're going to have to use references inside here, and then have string new name equals nothing, and then new int age equals 0. So we have string new name equals nothing, and then int new age also equal to nothing. And then inside our function, instead of having out parameters, we can actually use a reference, and we can say new name and then ref new age. And what that will do is we can just return it like this because it's void. Instead of declaring a new string name, we can actually just assign it to the reference it just passed, and because it's a void parameter now, and for the return type, we don't actually need to return anything. So we can actually assign these by reference. Enter your name, Abba, and 23. So as you can see, it still works fine. But let's say we wanted to add another birth month. So we'd have to take the birth month variable, new birth month, make it equal to 0, and then add yet another parameter, ref new birth month, and then we need a new birth month inside here, ref int birth month, and then we'd need another one from here, enter your birth month, and then we'd store it inside birth month. And then finally, we can also return it up here as a new birth month. There we go, Abba 23 and then 5. So we get them values being returned. So in order to keep adding different properties to your code, you have to make a new parameter, a new reference variable, and then append the parameters inside the function. Now the problem with that is, even though you can have an infinite amount of parameters, then this gets very tedious very quickly and you don't want this. So let's have a look at how we can make this function exactly the same way, just using our new structure. You can see that instead of having to pass all of these different things in, or return back a certain value, we can actually just return back a complete person. So all of this can be squished pretty quietly. So actually, let's just comment all of this out. And let's comment out this function, and let's have another rewrite. So now that everything's gone, we only want to be returning and dealing with the person. So we can say static, and instead of void, we actually want to say we want to give the user back a person. Return person, and we don't need any parameters in this case. This is only passed in because it's a reference, so we can assign these values back to the original variables. But because we're going to be returning a person, then we don't need to do that. So we can essentially take this code and put it in here. And we can say string name, then we have an int here, and then also an int here. There we go. So now that we've constructed all our variables that we need for the person, what we can do is we can make a new person, person, and then person.name equals name. And then duplicate this down, we can say person.age is equal to age, and finally the birth month is equal to the birth month. And then now that we've constructed our person, we still got a red underline because we haven't returned anything yet, and after all of that, we can say return person. There we go. And now simply in here, we could just say person equals return person. There we go. And then we can take this console write line here and place it straight underneath since it uses the same properties. Now let's try and run it. Abba 23 5. There you go. So now instead of having to make a whole new variable, all you have to do is simply just add another one down here. So we can just say number. This could be your favorite number or anything, and we can add it onto here. Person.number. And then here we can paste this down. We can say enter your number, and then it'll be number in here. We can paste it down here and change this to number. And there we go. That's all we need to change. And this code doesn't change because it's simply calling back the function and we're doing all the hard work inside here. So now if you run this, enter your name, Abba 23, 5, and finally 4. And there you go. We get the values being returned. So this looks a little bit tedious. We have to assign each one individually every single time we do it. So we can actually use something called a constructor in order to achieve this result. We make the person, we set them, and then we return it. It'd be easier if we could have the constructor that we can assign straight inside here and then just return it immediately instead of having to do all of these lines and then reference each one individually. So let's have a look and see what we can do. Inside here, we can have a new function that'll just be called whatever the structure is called. Then you open the brackets, close the brackets for now, and then this is called a constructor. In order to be able to use it down here, we need to make it public in order for someone else to access it. So this says that it needs explicit parameters in order to be able to compile. it says that it needs to assign name, age, birth month, and number. So let's see how we can do that. As we've used constructors in the past, for example, when we had things like the string builder, we had SB equals new string builder, and when you make a new something, that means you're making a new constructor. So all of these 6s are the parameters that go inside of this, but each one of these is a separate constructor. If we control click this, we should be able to see them all. There we go. You see that the class is called string builder, and this is called string builder, and these two names match exactly. So to make a string builder, you can give it any one of these as long as your parameters match one of these 6. You can give it nothing, or you can give it some other values. And that's the same is true with our current person. So what we need to do in this case is, we don't have multiple ways that we can construct this. In the case of our person, we have to provide all of these details, otherwise the compiler is not going to like it. So we can have a string name, int age, int birth month, and an int number. And now we've got our parameters set up, we actually need to make use of them in here. So because we have name, and they're exactly the same, string by string, then in here we can't say name equals name. In terms of global and local variables, this is global within the structure, as it's within these two curly braces, and all of these variables are only within these two curly braces. Local variables always take precedence over the main one. If I double click on this, you'll see that all 3 are referencing this constructor. If I double click on this, you'll see that both name references on line 20 down here is all referencing this one in the parameter and not the one up top. We want it to be assigned into here. So you have 2 options in this case. You could capitalize all of these, so then you don't run into this issue, and then instead of name equals name, it's capital N equals name, and that fixes it. Alternatively, if you want it to be a lowercase, then what you can simply do is you can place this dot. If you use this, it goes back to the current scope, and the current scope of name is going to be this, which is within the structure. When you use this, it doesn't reference the local variables, it references the global variables up here. So when I double click on this now, you'll see that that gets highlighted. So we can say this.age equals age, this.birthmonth equals birth month, and finally this.number equals number. So we're just getting all the parameters from here and putting them into these values. This might look a little bit redundant, but I'll show you why this is a lot cleaner. So back in our return person function, we have the variable and then we assign them all manually. But look how easy this now has become. If I comment out this return, we can say return person. So now we can reference person with a capital P this time because I want to reference the structure directly. So after the person, we can open the brackets and then start to type in. So our first one is name, age, and then birth month. Name, comma, age, comma, birth month, comma, and then number, comma. And then this is not going to like it because we also need to place new inside. As I said before, when you're making a string builder, you have a new keyword, and this new means that you want to create a new instance of this. You could think of this structure as a template. This is the template for something, and until you start using that something, it's actually not going to do anything. So we have to make a new instance of it because it's not already available, so we need to make it available through our data type. So when we say we want a new person, that gives us access to the constructor. If I remove that, you'll see we've got one of 2. Now we can create an empty person, and that will just make us assign all the values individually, but we don't want that. We want to use the second path, and if you drop the arrow, you'll be able to see the different parameters, which is the ones we just typed in. Name, age, birth month, and then number. And now that we've returned back this, we actually don't even need to do any of these lines right here. We can actually just return it exactly like this. So now if you run it again, you should see exactly the same output, 23, 5, and 4. Perfect. So let's just have a little recap. So normally when we're creating variables, we use common variables that we've used in the past. String, int, double, float, bool, etc. But with the use of structures, we can create our own group of variables and then we can use them variables inside functions and inside our code to make things a lot cleaner and a lot easier. So inside person, we actually store 4 different variables and they can be an infinite amount of variables should you will. And you can easily remove them and then remove them from the parameters and from the assignment, and then that's it. If we use this without our structure, then we're going to have to declare every single variable separately, and I know this is the same as doing it up here. It's actually a little bit more work because you need to create a new parameter and create all the new instances inside here and assign the values. Now the benefit of doing it within a structure is that when you go to do a function, look how easy this line is. Before, you'd have to have name, age, birth month all as references or have them as out parameters, and it gets a little bit long and a bit sloppy. In order to include the month in here, we'd have to have another int number, and you can see that the parameters are growing. If you wanted to store a user from a registration form, you might have name, address, phone number, country, and the list goes on. It can be a very long form, and therefore you'll have a lot of parameters. So it's very easy to wrap it around inside a structure and then simply reference it like that, and you'll need 0 parameters because everything is contained within the data type. And then inside here, we can ask for the user's details individually, store them as their integers and string variables, and then instead of using this notation, we can now use our fancy constructor where we can pass it in this exact order right here. Name, age, birth month, and then the number. Perfect. And then we can use it inside here. We can call each of these positions separately and concatenate them together. So now that we've covered structures, known by struct as the keyword, let's have a look at classes and how to define them syntactically. So we can make a struct called person, and we can give them a string name, and an int age, and to make them accessible, we'll make them public. And we can say public, person, string name, and int age. And that means we can assign these values using the constructor. So we can say this.name equals name, and this.age equals age. Perfect. So let's get rid of our compiler error since we're assigning both the values. And then down here we can use it. We can say person, person equals new person, and then have ABBA, and then 23 in the brackets. And we can print to the screen person.name, and then if we use Ctrl D to duplicate that down, and we can do .age, and if we run that right now, we should see ABBA and 23 being printed to the console. Perfect. So as we talked about in introduction, syntactically the struct and the classes are very similar. So let's comment this out so we don't get any compiler errors, and let's see how this is going to work. So of course we're going to get error on this line, but once we make our class, the error should disappear from here. So instead of struct person, we're simply just going to have class person. Exactly the same, and because these are fields, we can also copy these down. So we can have public string name and public int age. And then we can have public person, and then string name, int age, this.name equals name, and this.age equals age. So as you can see, this is exactly the same as this, except for the fact we have structure, and we have class inside here. Now you see our compiler error is gone, and if we run the code, we should see exactly the same output. There we go. Now the main difference about classes and about structures is that you don't actually have to give these a default value inside the constructor. If we just comment this one out for a second, and if we bring the structure back, and we actually remove the parameters from here, then we're actually going to get compiler errors, and it says that the name and age must be assigned before it's returned, and structs cannot have parameterless constructors. Now that's a bit of a problem in certain cases. You might want to create an instance of something but not actually derive any values. So you could actually make these into default values. You can have string name equals nothing and int age equals 0, and therefore once we place it inside here, then there's no problems. If you run the code, then you will get the output, this will be nothing, this will be 0, and you'll get errors. And you won't get any compiler errors doing it this way, but the point is, you have to include them and you don't have a choice. So if we just comment this back out, now what you'll notice about the class person is even if we get rid of it, then it still lets us have it. Of course we can't actually give it parameters since we don't have a constructor that lets us have parameters, but what you can do as well is you can overload this and actually include it as well. So you can have another set that literally lets you define both of them. And then you can even have another overload that lets you just include the name without the age. And then also another one that lets you include the int age without the name. Or you can include both the details. So in these cases what you can do is you can store the values up here as the fields, let them use a default constructor, or only give it the name or the age, or you can actually give it both. So when we come down into here, we actually now have 4 different constructors. We can make an empty person, we can make it with an age, with the name, or with both. And what you can do in here is you can say this.name is equal to nothing, and then here you can say this.age is equal to -1, just to default it to a value that's incorrect. So after we've got this, let's have a look at the different ways. So we can give it a person, which gives us an empty value. So if you run that now, we get blank and 0. And if we just give it the name, which is ABBA, then we should get ABBA and -1. Yep. And then if we just give it the age, you should get nothing in 23. And if you actually give them both, then you should get both printed out to the screen. And there we go. So now we have 4 different ways that we can create our person. With our structure, we're only really limited to 1, since all of these values need to be assigned as the structure is created. Structures are meant to be used as an extension to a data type rather than almost like a mini management system. When we make a class, we have so many options of different ways that we can do this inside here, and later on in the course we're going to show you how to include functions inside here and then eventually do other advanced techniques with classes that aren't directly available with structures. If you have a basic example where you want to extend something to use inside a function or a data type like storing name and age, instead of having to do 2 return types inside a function, then a struct is perfect. The second you want to do more complicated things or make it a bit more specific and flexible, then classes are the way forward. You'll see it very often in games where they have a struct position. You'll see it in video games where they have something like a struct position, and they might have int x, int y, and int z. And that's for their 3D position, or they might even just have an x and y, or you could have something simple like a rectangle, and you can give it a width and a length. So now when you use that inside the code, you're going to have different flexibilities of the amount of data types that you can store, and then when you return that back from a function, that'll be okay as well, since you can use this as a data type. So if you want something simple and straightforward, then go for the struct. The second you want something a bit more complicated and a bit flexible, then you probably want a class. We'll go into more different situations inside this course so you understand in which cases to use what, and in most cases you'll notice that the class is more applicable. So if you wanted to, you could ask the user to enter these details in, and then you can pass them inside the constructor. So we could say console write line, change this to a write, enter your name, string name, console.readline, and then copy and paste this down, change this into a int age, and then wrap this around inside a convert in 32. Instead of enter your name, it'll be enter your age. And then since these are grayed out, it means we haven't used them, so we can change ABBA to your name, and then change 23 to age. Perfect. So now if we run the code now, enter your name, ABBA, enter your age 23. Then we get ABBA 23 printed out to the screen. So just a quick recap. Constructors are basically defined the same way. You have public, followed by the class or the structure name, and then the parameters inside the brackets, and then you can assign it after. With our structure, you have to declare all of the variables inside the parameter and assign them all down here, otherwise you won't be able to run your code. With classes, we have the flexibility of just including one default function, which will just be our constructor, and even if it does nothing, this is still acceptable. And then we broke it down into multiple sections, where you might have situations where you only want their name, or their age, or you might even collect both to store it. If you collect their name, then we'll initialize age to -1, just so you know that this is a bad value, and if you declare only the age, then we'll initialize aim to nothing, just so you know that it's an empty value, and if you accept both, then we simply assign both. And down here, we have access to it. We can even make this a little bit better by checking these values. So we can say if string is not null or empty of person.name, and we can put a not inside here, then we can print out this. And then the same thing for age, we can say if person.age, we can say greater than -1, since we set -1 as the bad value. And then we can move this line up, and let's try run it now. So these two if statements are fundamentally separate from each other. One is checking the name, and one is checking the age. So let's try and manually type these in and see what happens. So enter your name, let's make this blank and only include the age, and let's see if this runs okay. So we add no name and the age is 23, then you see we only get printed 23, because it'll skip over this line. As you can see, if we put a breakpoint in now and just refresh the code, we get empty name plus 23, and when we press F10 over this line, it jumps to the next one, because if we hover over this, you'll see that it should return us back with false. There we go, we get string is null or empty is false. So that'll skip over that, and because the age is 23, then this line is going to execute. Let's run it again and do the opposite. We could say name is ABBA, and then age is -1, and then we get ABBA printed, but not the age. There we go. So if we wanted to fix these in and type them manually, so we can say 23. There we go, we get 23, and if we only include the name, ABBA, then we only get ABBA printed out, and if we include both of them, then we get them both printed out. Perfect. So now that we've created our class, we've gave it some fields and we've made our constructor that lets us initialize it. Let's see how we can print the details out to the console. So we can have a CW tab, a console write line, and then we can say string interpolation, name, colon, space, and then we can have our curly braces and we can say person.name. We can access these fields using the dot operator, and then we can say \n for the new line, and then say age and the same thing, person.age. Let's try run that and see what we've got. So now we've outputted name and age out to the screen. Let's see how we can do this inside a function. If you wanted to place this in different parts of your code, then you're going to have to copy and paste this, and as we know, this is bad for our code because it's data duplication. We want to be able to wrap this inside a function somewhere. So let's see what we can do. We can have a static string, so you can return us back with this that we can output straight to the console, and we can say return details. And for our parameter, we can have something like string name and int age because that's what our class is made up of. And inside here, we can simply take this, put it inside here and put a return before it, and then get rid of the person dot since we have an name and age variables as local to the function. So now instead of this line, we can duplicate this down, take out the contents, and we can say return details, and then we can place person.name and person.age inside here. Let's run the code. So we get exactly the same output, but the problem with this function is we're having to type out the parameters manually. We have them here, and we're going to have to type them again in here, and again for the parameters. This is a bit of a problem because we've just made our class, but we haven't really used it when we're passing it in. So instead of having string name and int age, we can actually duplicate this method and just comment it out, just so you can see it for reference. And instead of doing this, you can actually just pass in an entire person. So now we have access to person, and we can bring this back and we can say person.name, and we can also say person.age. And the reason why this method is preferred is if you actually have something else, public int number, and then you added another one inside here, int number, and then you said this.number equals number, the parameters won't have to change inside the function. All you have to do is simply pass in the person, and then now we actually have access to doing person.number inside here, should we need to. If you're passing them all in one by one like this, then you have to append int number on the end, and then add it straight to here. And then also add it inside here as you have like this. It's easier to pass the class in because all of these properties above are just simply used throughout the function. So now if we just bring this back, and let's have a run and see if we get the same output. Which we do, name Abba, age 23. Perfect. So now that we've thought of two functions how to do this, we can manually type in the strings and the integer and any other parameters that we need, or we can actually pass in the person. The problem with these two approaches is the whole point of having classes and structures of the like is so we can wrap around lots of functionality inside it. If we want to send this to another developer for them to use in their project, or maybe this is a file that is shared within the projects, then you don't want them to include a separate function that is simply outside of the class. We want to include the functions inside the class. So of course, as you know, these are functions. So inside here, we can also make functions. So let's do it. So we can have public, and we want a string, return details, and then we don't need to pass anything in. The values that we're going to be returning are these two right here, which is technically local to our class. So therefore, we're not going to have any parameters. I'll explain that further in a second. So we can take this exact line, paste it straight into here, and get rid of the person dot, and get rid of the person dot on this side. So then we have the name variable and the age variable. If you double click on them, you see it references these variables, and the same thing for age. The reason why we don't have parameters is when you call this function, as I'll show you in a second, you call it directly on the person. So the person that you're trying to print has already got these contents inside of them. So let's have a look. We can duplicate this down, and instead of calling return details and passing the person, you actually do it the other way around. You say the person object dot return details. So now we're calling return details inside our person object. Now let's run the code. You see that the output is exactly the same, except now this functionality is a lot better. Our return details is wrapped inside our class, which is the preferred way. And now we can actually get rid of these inside here. And then we shouldn't really use this notation, even though it is technically correct, but you want to wrap all your functionality inside here. And just bear in mind that scope is also applicable here. Return details is within this class, which means if you try to run this function inside the main, then it's not going to know it exists. This return details function was able to be used inside here because this was in the scope of the class program, which is this curly brace and this curly brace. But this return details is only within the scope of this class, which means you can't just suddenly use it inside the main. So please bear that in mind when you're producing these classes and you're trying to understand where everything goes. Every function that you place inside here is accessible through the dot notation after the object once you've created the class. Say person equals new person, and then after we type person dot, then we'll get a list of all the functions. The same way if you have something else, just like this, and then if you do person dot, and then you see that something has appeared there. So all the functions that you create up inside in this class, for every person that you make, it'll be accessible through the dot notation. So just to round up this video, you should always make your functions inside your class. Having them inside the class is the whole point of making a big class and have lots of functionality inside. If you keep the function that does exactly the same thing outside of the class, then if you were to share this file or come back to it in the future, then you're not going to understand why you've done this and it's outside the class. Keeping everything wrapped inside the class is the best way forward in most case scenarios. So now we have our class person. It's got a name and an age, a constructor, and a function to return back the details, and we can simply use it like this and return back the details like this. But so far we've covered how to make classes, constructors, etc. and assign the values, but the values are only getting assigned throughout the constructor. But what if a different part of our program, the user wants to change their name or update their age, etc. Then what options do we have? So you know we can access our fields using person.name, and then you can simply type equals, and then type in another name, and we can say person.age equals 25. Now we've changed these properties. If we use the console write line and return details, you'll see that the values have indeed changed. As you can see there, it's changed to Harry and 25. This is okay, except for the fact that this shouldn't really be possible. We should try and restrict this directly by the use of getters and setters. So for now we're going to cover fields and how to restrict certain values, and later on in the course we're going to go through what properties are. So before auto properties got invented, we had to use getters and setters. Getters and setters are essentially functions that'll prevent this from happening. So the reason why we can do this is simply because this public word is placed right here. If we change it to private, it means that name is still accessible within here and here, which is only the limits of the class, but as you can see, it's not applicable here. This is why you need the public getters and setters. So I'll explain what that means now. So we prevent these from accessing outside the class by making them private, so this functionality no longer works. So what you have to do instead is for every field that you have, you need to create a getter and a setter function. So in order to set a value, we can have public, and because we're setting it, we don't need to return anything, so it'll be void. And we can say set name, and then we pass in string name. And then we simply just say this.name equals name. So when someone calls set name and pass in the name like this, we just override it. So let's see how that looks. So if we comment these two lines out, we can simply say person.setName, and then we can say Harry. So this line is directly replaced by this line. And now if we run this, we'll see that Harry should be changed. There you go, Abba is changed to Harry. This is really powerful because what we can do now is restrict the access inside here and make sure that the value contains something genuine. We can say if string is null or empty and then pass the name inside there. If the string isn't null or empty, then we assign it. And if it is null or empty, then what we can do inside here is we can say else this.name equals nothing, and we can keep it blank, or we can use string.empty, just to make sure that we know that the name has been blanked out if they've entered something invalid. If they've entered something that's valid, we assign it. If it's invalid, then we don't assign it, and we just initialize it back to nothing. And because our options are endless with this, we can actually make this into something else. We can simply just say invalid name. So then what happens is, if we try and change this to nothing, and we run the code, we can see that we get invalid name being printed to the screen. And that's a lot better than if we had string.empty, because if you had string.empty, then it would kind of say nothing. Then it looks like something's went wrong. If you have something like invalid, then that gives you a bit of a better message. So we can have invalid name there. So using our setter lets us change our name from down here without directly exposing the public. If we expose the public, then everyone who uses classes can simply change the name to whatever they want. Having it private and only changing the name within the set name function is very preferable because you can restrict the access and what people can set the values to. If they try to set it to something that's not valid, then we set it to invalid name. Whereas before, when we did this, and if we make this public again, we can simply set this to something bad like null. Null is a very bad value, but it still lets us have it. And the reason why it's very bad is if you try to do something like this, person.equals, and just some empty brackets. Now, even if I just leave this empty, the fact that you try call equals on side person.name is going to be a bit of a problem. So we can say person object, the name property inside it, and we're checking if it equals to ABBA, for example. But because we've just set it to null, let's see what happens. You see that we actually get an exception. It's a null reference exception because if you hover over name, you see that it returns back null. Nulls are very bad in this case. Whereas if we actually bring our function back, and we make this into a private, and then if we try and take this value, our null value, and place it straight inside our set name, if you uncomment it, get rid of the quotation marks, and if you actually try and assign it to null, let's see what happens. Then we're going to get invalid name, and this prevents us from breaking our code if a function like equals were to be called on any of our properties inside of name. So now that we've done it for our name, we can also do it for our age. But before we do that, we can also call a function called getName. Return details gives you back these details in a very specific fashion. But what if you wanted to do something like this? Your name is, and then you wanted to do person.name. But of course you can't do that because name is no longer public, so you can't reference it directly. So we've got a set name, and then now we need to do a getName. So we can have public, and because name is a string, the return type is going to be string, and we can say getName. And this function is very simple, it just returns back name. And that's it. There's no parameters because all it does is return back a value. And in this case, it's just returning back name. So instead of using person.name in here, we can say person.getName. Open close the brackets to indicate it's a function, but there's no parameters. Now you see that we have no compiler errors. So now if you run that, you'll see that it says your name is invalid name. So let's actually give it a value. And we can say Harry again. Run the code. There you go. Your name is Harry, so it's officially changed it. And now let's work on the age. So just following the exact same approach, we can have a public void set age int age. And instead of just doing this.age equals age, let's try set some boundaries on this. We can wrap this inside an if statement. So as for the condition, we want to validate if the age is successful. So we want to do if age is greater than or equal to 0 and age is less than or equal to 150. So this means if the age is less than 0 or greater than 150, then this is going to return back false, and then it's not going to assign the value, and we can simply assign it to -1. -1 is just so we know it's a bad value. So now that we've created our set age, we can actually make our get age. So we want to return back an int because that's going to be the data type for our age. So we do public int get age. We don't need any parameters because as like the name, we're just simply returning something. So we can say return age. So now that we've made the set age and the get age, let's actually use it in our code. So we've made our set name, and let's say person.setAge, and we have 25 inside here, just like above. And then now that we've set the age, let's append this sentence. We can say and your age is, and then person.getAge. Perfect. So let's run the code and see what happens. There we go, we have 25 and Harry being changed. So another little tip when we do in this code. Our getAge is one line, and our setAge is a couple of lines, but we're fundamentally only assigning age. So what we can do is, we can make these into the tertiary operator. So as we can see here, this is the condition. If this returns back true, then we assign age, our local parameter, and if this returns back false, we assign -1. So we can actually make this into this.age equals, and if you remember the format of our conditional operator, we use condition, true, and then condition, false. So this is our condition that is leading our if statement, and if this returns back true, then we do question mark and put age in there, and then colon. If it returns back false, then it's simply -1. There we go. So this has actually been entirely replaced by this one simple line. And we can do the same thing for our string. So we can say this.name is equal to string.is null or empty, pass the name inside there, and if that is true, then we assign it to name, and if that is false, we say invalid name. Let's comment this one out and let's see if our code runs okay still. Harry25, Harry25. And now let's try our bad values. So we can try set the age to 200 and the value to nothing, and let's see what happens. We get invalid name, -1, and there you go. Perfect, so that's working okay. Let's undo them values, and you can see that this has been shortened completely. Another top tip for functions like this, you can actually use something called arrow functions, and if you've done any JavaScript, this might be quite familiar. So we can have our getAge, and instead of opening the curly brace at this point, we can actually place this arrow inside. So if we comment out this one, with arrow functions you can only return back one simple line. So because this is only one line, we can have return age. But arrow functions don't like the keyword return. Any variable that you put straight inside here is automatically applied that it's a return type. So we literally just put age. GetAge returns us back with age. If this is confusing, then stick to this approach. But this might tidy up your code, because instead of having all of this and all the curly braces for one simple line, you can use arrow function. So if we actually copy and paste, but first comment out all of these functions, you can see how small the code can actually get. There we go. And then let's actually have a public void setAge. Let's put our arrow function in, and then we can take this one line and paste it straight into here. So you can see that these two lines are now being replaced by all of this. And of course we need our int age inside here. There we go. So now we can do the same thing with our set name. We can take this, we can have public void set name, string name, and then have our arrow function, and then simply paste that in. You can see that this will get a little bit long now, but it's still ideal. I've got the code zoomed in, but if you put that to 100%, you see that this code is actually pretty small. It's just I've zoomed in just so you can see the code a lot clearer. And then finally for public string, and we can get name, and then we simply just do arrow and then name. And you can see that with all this other code commented, we're just relying on these functions as we just created, and you'll see there's no console errors or anything else. So if you try and run it, you'll see that everything is going okay. Of course, if you don't like this notation, then you don't have to include it. You can stick with the curly braces. I don't use the arrow functions a lot in practice because there isn't many situations where you'd actually use them, and even if you do, some people might not like them, or there might be certain guidelines that you might be following inside a company. What I do suggest you stick with is the tertiary operator. These are a lot good and a lot better to use since it reduces the code drastically. If we actually remove this, and I'll paste it back in just so you can see it for reference inside the resources, but you can see that these four functions are now reduced to on one page. You can see that they're all got one lines and they're pretty short. So let me undo that just so you can see the original code and have it for reference. So there's a lot covered inside this video, so let's just have a little recap before we finish up. So just to start at the beginning, when we initialize our person with their name and their age, we don't actually have any other opportunities to change their value, which is where this comes in. You can actually just say person.name and assign any sort of value. You can put anything inside there and it will assign it directly, unconditionally. The problems with doing this is someone might expose it to null by accident, and somewhere in your code, if you're using something like equals, this will actually prevent an exception. Of course, you can wrap this inside a try catch, but this is unnecessary because we can prevent this in the first place. It's always best to prevent an exception than to put additional code in like a try catch in order to catch something that you can prevent in the first place. Prevention is definitely better than the cure in this case. So having something like person.name being exposed, it's not so much for the integer because integers will always have number values, whereas strings, they can be initialized to null. There is no such thing as null in our age. Our default value for an integer is 0, so we don't really have the same issue. We started introducing the name function and the age function. These are used so we can control what values get assigned to our local variables. And we also have our get functions, getName and getAge. So let's explore how these are made inside our class and expand on that and see how they work. So first, we need to make sure that our variables are actually private. They're private so we can't access them just like this. If I copy and paste this line above, you'll see we're going to get a compiler error. And this error is because we can't actually use it because, as it says here, it's inaccessible due to its protection level. And the protection level comes from the fact that this is indeed private. It's private, so it's only accessible within class person. So every reference to name can be used inside here, just not outside. So the only way to be able to change the name now you've made it private is by enforcing this function. The good thing about this function is we can check if the value is invalid, and then we can store it if it's valid, and then change it to something else if it's invalid. And then we can wrap this if statement around in a conditional operator just to make it a little bit shorter. And in order to retrieve a name, because now that we made it public, we can neither set or retrieve it. So we have our getName function that simply just returns it back to the screen. Nothing special here. And the same thing for our setAge. We can check if the age is between 0 and 150 and assign it, and if it's not, assign it to -1, and then again wrap it around in our conditional operator. And then for our getAge, we can just return age. I demonstrated arrow functions inside here. You can take all of these one-line functions and actually add them all in one line without the need of curly braces. If you want to return back an age, then you simply just type in age, just like you can see here and here. When you do assignment, you want to specify this.name equals, but when you're doing returns, you just need to type in the variable that you need. Of course, this looks a little bit cleaner and a bit shorter, but not everyone likes this notation, so it's completely up to the developer or the environment that you're working in. And finally, we just have our return details. And then we can make use of them just like this by using person, which is the name of our local variable for our new instance, followed by a dot, and then setName, setAge, and then getName, and then getAge. So now that we're dealing with classes, it's important you focus on the scope. We have a person here that's defined within the main, which means it's only within these two curly braces. So if we had a static void and a function that did something inside here, we can't access person inside here. If we take out the comment and we try it, the only reference we have is accessing the class directly, not this local variable. If you want to access the local variable from inside this function, then you'd simply have to pass it in like this, and then it'll finally become available. As you can see now there's 2, and it says as a parameter. And the same goes for this class above. Just because we have name and age up here, it doesn't necessarily mean that we can magically use name down here. If we have something like a static int defined right here, then we can use this integer inside these functions. As it says there, it's available. We can assign that to 10, and it's also down here available, and we can assign that one to 20. And you'll see we have no compiler errors. But if we take this and put it inside our return details function, then you're going to get an exception because X is not available within that scope. And the functional scope matters inside here as well. If you have a string test inside here, we can't just access it in another function, for example the constructor. We can't just print out test as a screen. The handy things with classes, if you want variables to be available throughout the class, then you put them at the top. We can have that private string test, and there you go, you see that the compiler error is now gone. And we can give that initial value, and then you can use that to print to the screen, etc. And just a note, when you have a variable that's called exactly the same thing, we have a private string test up here, and we can say hello, and then we also have a string test down here. So let me demonstrate what happens when two variables are the same. So let's move this into our constructor. So if we run this as it is, test equals hello, and then we print out test, and then to run the code. There you go, we get hello printed, and just ignore this is from the return details function. As we've got in the main down here, return details. So we've made our new constructor, and then assigned it the value of Abba and 23, and then we can get hello printed to the screen. But let's say we actually made a string test inside here, and we said hi instead of hello. Then which one do you think gets used? The global one or the local one? Let's run it and find out. It's actually the local one. The compiler will always prioritize the local variables over the global variables, and this is the reason why you need to type this dot, because when you use name, it's always going to reference the parameter when it's name on its own. If you use console write line and say name, and then if we do after this line another console write line and we say this.name, then these are completely different. This one is the parameter, and this one is talking about the variables from the class, and these are known as our fields. Local variables take precedence over our fields, as long as they're called the same thing. As you can see now, it says it's assigned, but the value is never used. If you take the string test out, then you can see it's now being used. There you go, hello gets printed out to the screen, and there you go, the green line has went because we're using it down here. Scope is very important when you're designing these classes, And just to note that the variables that are available inside here are not going to be necessarily available inside here unless you make them public. And even when you make them public, that doesn't necessarily mean that this is still available magically over here. Name will only be available through an instance of the person class. So if we do person.name, now we can see that that's available as our field. So that's why that makes it public. If we try and make this private again just to return that value back, and we scroll down, you'll see now we get a compiler error because it's inaccessible, because it's outside the scope, because it's now a private variable. So we've covered what it means to have a public or a private field. If you have a private field, then you're going to have to use setters and getters in order to work with this field. If you make it directly public, then you won't need any setters and getters because the user can just type in .name after their public instance. So you can have person followed by the dot. And right now, you can't see name inside here, and the blue little icon is no longer there. And the reason why it's not there is because there's no public fields. If we then change this to public, remove the dot and re-add it, you'll see that our blue square is now back, because our field is now accessible, and we can assign that to anything that we want. The whole point of making this private is you only restrict the access so you know what you're doing. And the reason why I say that is, if they enter something that's invalid, then we want to specify something like invalid. If we give them public access, then we're not going to know and we won't be able to validate what they've entered. So in order to do it through a setter, we can make it private, create our set function with a return type. It's going to take in a string parameter, and this string has to be the same data type as the parameter you're talking about. Call it name or whatever you want it to be, and because these two are called exactly the same thing, we have to use this dot, so we're referencing this name instead of this name in the parameters. And here we're just using a conditional operator, and we're saying if the string is not null or empty, hence the exclamation point, then we assign it to name. Name gets put in this .name. And if this were to return back false, then we place invalid name straight into this .name. And for the get, we simply just return a string, since that's a data type for name, and then just return it back, and it's that simple. And the same thing for age, we validate the age range, set it, and if it's outside this range, we can set it to -1. So as you can see, this is a bit long. We have our private variables, and then we have two functions, one for set, one for get, and the same thing for age. So these are called fields and getters and setters. So I'm going to introduce a notion called properties, and properties make it easier to do this exact notation. So let's now see how a property is created. Since these fields are private, we need to make something that's actually public. So we can do something like this. We can say public string, and we can say name with a capital N. So now you can see that name and name are not actually clashing, and we can assign that in here should we want to. And you see we don't need this dot anymore because this is now different. It's a capital N, so this one always references this, and this references this. So we need to add something else onto here. So if you create them both, now you can see we can do age equals age, and there'll be no problems with this. So now that we've made our two new fields, so now we have our two new public variables which are known as our fields, let's see how we can turn them into properties. So if you remove the semicolon, you can actually add in some curly braces. So inside here, we need a getter and setter, just like we had down there, but we have a quicker notation for it. Instead of making two distinct functions, you can actually create a little section inside these curly braces to get and set the name. So you've got to think of this as a middleman, the same way this is a middleman. We call this function, and this function will affect the name. And this is going to be the same principle. We make use of name with a capital N, but it will actually be affecting the lowercase n variable. These are going to be our new middlemans, and they will directly replace the getters and setters here. So what we can do in here is we can say get, press enter, go on the next line and make some curly braces. And then we can also have a set. So this is like our mini get and mini set function, just like we've got here, but as you can see it's a lot shorter. We don't need to give it a distinct name or set the public or anything else, we just give it a simple set and get. So if you have a look at the compiler error, it says not all called paths return a value, because as it says here, this get function is actually a mini function built into this property. Person.name, which is our name with a capital N, and then it's .get, and this returns back a string. So if we actually just type in return this, then it gets rid of the compiler error. But of course we don't want to return nothing, we actually want to return name. Because remember what I said, string name and int age up here as our private fields, they actually store the data. The public string name and the public int age is the middlemans that coordinates all of the getters and setters to do with the private variables. So for the set, just for now we can say name equals, and then what do we give it the value of? So if we hover over set, it doesn't actually give you any indication of what it's going to be. So let's have a look. If we press Control space, then we don't also get the list of everything that we can add inside here. Now it's very difficult to understand what to assign this to. When we have set name, we've given it a string name parameter, so we can use name down here. So what's our parameter in this case? Well, the function itself doesn't actually tell us, but I'm telling you right now that the parameter is actually just called value. And this is a very default parameter that you'll see everywhere when you're doing getters and setters inside a property. You don't have to specify value or anything, it just gets simply assigned in. Just like here, where we have string name, this will be a string value. So it will look something like this behind the scenes, but of course you can't actually type this in. Because remember, these properties are trying to give you a shorthand on how to do getters and setters. So you just got to remember that when you're trying to set, you get the property inserted as value so you can store that into name. So that's it, the name is actually sorted now. So before we do the same thing for age, let's see how we can use this inside the code. So if we scroll down to our main, we have a person, and then we have a console write line that prints the details. So we can actually do person dot, and you can see now that it's slightly different. If you ignore the age, since that's returned back as a field since we haven't done that yet, you'll see that name now has a little cog next to it, show only properties. This is a new icon that we haven't saw yet, so this is our new icon. It says it's going to return us back with a string, and we can actually execute a get and execute a set straight on this name. Then we can say name equals Harry, and we don't get any compiler errors whatsoever. This lets us do it completely. So now if we do another console write line and we say person.return details, and let's run that, and you should see that the name gets changed. There we go, Abba gets changed to Harry. Perfect. So after we've got person.name, let's see how we can also get the value. So we can just say string interpolation, your name is, and then we do person, and then followed by a dot. And as you can see, the exact same list that we got given over here is given right here as well. Name also says get and set, and it returns back a property, which is a string type. So we can open it like this, and you'll notice that we don't have the parentheses after it. And the reason for that is because the brackets indicate that you're calling a function, but a property is just a property. It's almost like a variable. So you're not actually needing to put any brackets after it because there's no function to call. So as you can see, this is exactly the same as this. In this case, we're actually setting the value, and in this case, we're actually getting the value. So let's comment this line out, and let's see what happens. Your name is Harry. So that's worked okay. So now let's do the same thing for age. Remove the semicolon, add the curly brace, we can say get, and then return age, and then simply do set, and then do age equals value. There we go, so now we've got that set up. If we return back down here and we see person dot, so as you can see now, the age is being removed as being a field, as we saw in the blue icon, it's now been turned into a spanner, which means it's a property. As shown here, show only properties. So now you can see it returns back an integer, and we've got a get and a set. So we can set that to 25 for example, and then we can append onto here, and your age is person.age. You can see that it's a capital A, just as this one is a capital N, and now we have get and set available, and again we don't need the brackets inside here, since this is a property, not a function. Now let's run it, we should see Harry 25. There you go, your name is Harry and your age is 25. Perfect. So as you can see now is, instead of having our set name and get name, which are these two functions, we actually have them contained within a property. We call this property and it affects these variables, but as you can see, just as these functions below were a middleman, we've now moved the middleman into these properties. So, as these are only one line, you're probably thinking, there's probably a better way of doing this, and it's a lot quicker for syntax. And you're right, there is, so let's explore that. So I said before about arrow functions. When you're doing something like this get name, you can have public, string, get name, and then you can simply do arrow name. And this is a very common string function, get name, that just returns back a value, and you can make that into an arrow function by literally just putting back name. So we can actually do the same thing, but for our properties. So these both contain one line. So we can actually minimize this. And if we just block comment this out, we can say public string name, and then we can have get, and then the same thing with the arrow function. When we're doing the arrow function down here, you would simply won't use the return keyword, you would just type in the variable you want to return. So we can say get arrow, and then simply lowercase name, and then add a semicolon, just so you know that that section is ended, and then straight after it we can have set, and then arrow, and then name equals value. Just like that. So as you can see, these contents are exactly the same, but you've actually returned them back in a shorter space. And of course here, as we got a compiler error, it just expects a semicolon to be right at the end here. There you go. And now we do the same thing for our age. We can do public int age, get arrow age, and set arrow age equals value. Perfect. So now you can see that this has been drastically reduced. If I cut this just underneath, you'll see that almost all of these lines are just replaced into 2. And you'll see that our functionality will still work exactly the same if we just run the code. Harry and 25 is being reassigned over our default variables. Perfect. Of course, now if you want to add some more functionality inside here, for example, in our set name, we had a little check that makes sure that it's a valid name before we assign it. So we actually take this and paste it over here, then you see the lines grown quite a lot. So what's best to do is, if you're going to have any data inside here that does a little bit of logic, then it's best to keep the curly braces since you can have a bigger output and it looks a bit more sensible. If you're just simply getting and you're setting the variables, then you can leave this notation. So let's undo this and bring back the original ones in this case. There we go. And then we can take that line and in the set, we can actually replace it here. So as you can see, this is a little bit grayed out. So let's put the semicolon at the end and let's see why this is grayed out. Name can be simplified. So what we're doing now is name and all of these variables are actually looking at the private variable. Whereas if you actually look down here and we uncomment this, you'll see that set name, if we double click on this one, this is the only reference to it, which is our private variable up here. And the reason why this doesn't need to be used in this case is because our parameter is now called value. So it's saying the name is equal to, checking if the value is null or empty, assigning the value into name if not, and then if it is empty, then we assign invalid straight into name. In the case of our set name, our name was our parameter. The same goes here. If we change this to value, we can change these two for value. As you can see, now this dot is actually grayed out and it can be simplified to just simply name. And the same principle applies above. So let's comment these back out and scroll back to the top. So now that we've assigned name, there we go. We've got our check inside there, and you can also leave this on one line if you want. You can even drop the curly brace in just so it looks like this, instead of having it all on one line. So you could do this, and this would be applicable as well. But the second you start to put it all on one line, then it gets a little bit messy quickly. So if you leave the outer bracket just like that, then it can be pretty short since you don't need more curly braces. So now that we've done that for the name, let's do it for the age as well. So we had this.age, we check the range and we assign the relevant values. So let's take that, paste it over this. We don't need this dot anymore, and age in this case is actually going to be the value that gets passed in. So replace all the ages with value. There we go. So if the value passes the range check, we put the value inside age, or not, we can put -1 inside age. And again, we can have the same thing. We can use our arrows inside here. There we go. So now we've got our code drastically reduced. So we went from these big functions that have to be defined with specific names over to our properties, and they went from really small to just a little bit bigger, but now they have advanced connections just to make sure that the variables are okay before you assign it in. So now that we've got our properties, let's have a look. So inside our constructor, we don't also need to use our local variables, which is our private ones directly. We should actually get rid of this now, and we should always do everything through our properties. Name equals name, and because this is a capital and this is a lowercase, we don't need this dot in there. There we go. So what you should do in the return details function is also use the capital N and the capital age. So when you hover over these, you're actually referring to the property. Because like I said before, these are the middleman to communicate with the private variables. You shouldn't need to access the private variables directly, you should use the middleman as much as possible. So now that we've done that, I have one last thing to introduce. So if you actually abandon all of this code just to keep it for reference, we have something called an auto property. And you briefly saw it when we saw it down here. So if you actually just bring them back for a second, and if you hover over name down here, it says string, name, get and set in the curly brace. But you see how the get and set is empty, it just has two values inside there, and it just ends a curly brace with no actual logic. You see in our get, we're saying age, and our set, we're saying age equals this. So when we're doing auto properties, what you can do is you can actually make these public again. Change these to a capital N, change this to a capital A, and just straight after it you can say get, set, just like that. And what that will do is, although they're actually made public, what it's doing behind the scenes is actually doing this for you. It actually has a private and a public for you behind the scenes. This is just a shorthand. These are what's called a auto property. What it does is it makes an anonymous property behind the scenes, as I'll show you in Microsoft documentation right now. As it says here, in C# 3 or later, auto-implemented properties make property declaration more concise when no additional logic is required. And what that means is, no additional logic, all of these are additional logic. If you're just simply assigning a value and reading it back just like here, then this is no need to write get name and set name if all you're doing is getting and setting it. If you're getting and setting it but there is a certain amount of logic, as we have here, we essentially have a conditional operator that's making a subconscious decision about what to assign the name to. But if you're just simply assigning something like this, then an auto property is perfect. They also enable client code to create objects. When you declare a property as shown in the following example, the compiler creates a private, anonymous backing field that can only be accessed through the properties get and setters. As you can see here, just like in our example, we have public int something and then get and set. And then they have a public int something with the get and set as well, and they can use it just here to access it directly. And because they're simply just assigning and getting the values and there isn't any additional logic, then this is the best way to do it, and you get, as it says here, an anonymous private backing field. So this would be the same thing as doing this. Private string name and private int age. So once you do that, and you make this into the get and set properties, which are these two right here, this and this line together make a property. What the auto-implemented property does is actually combine this line and this line together and make the private one behind the scenes so the programmer doesn't see it, but it will be applicable when the program runs in the compiler, and then you only get publicly exposed with this parameter, which will be our name property. So it will actually make the private for you if you just keep it like we had it a second ago. Just like this. So if you leave it like this, it will actually create the private variable behind the scenes. As it says here, it's anonymous backing field, and it can only be accessed through name and age. And as you can see, none of our code has actually changed. All of these still function okay, and if we run the code, we should still get Harry and 25. So just to sum this video up, since there was a lot covered, the bottom line is, if you're going to have any sort of values that require any logic, then you should use normal properties. If you're simply just going to assign and get the value, and it doesn't matter and you have no control over it, then you can use the auto-implemented properties, since that will do the same thing with less code. Using the getters and setters is the old way of doing this, and you should always use the properties going forward. Getters and setters are very helpful to know, just so you understand what they are and why they exist, but you should note that properties are the best way forward. Properties give you access to doing the same logic as it says inside here. If you're doing auto-implemented properties, then you're not allowed to use the logic inside the set or the get. So if you don't want to do any logic, then don't use the auto-implemented properties, only use the normal properties. To make a getter and setter, you just do set name, get the parameter and assign the local variable, and the get just returns it. Getting back a property, you want to capitalize your private variable. If you had private string name with a lowercase n, you want public string name with a capital N. You get the name, and then you can set the name with some sort of conditional operator or any if statement or anything inside here. And the same thing goes with the age. You can have a public int age with a capital A and a private int age with a lowercase a. You can get the age and then set the age with a conditional operator again or any other code. If you don't require any logic like these two lines indicate, then you can simply just use the auto properties as demonstrated above here, and they can be used quite easily throughout the constructor and our functions, and even outside the function when the user is trying to call them. But one thing that we haven't been able to solve, and you may not have noticed this as a nuisance, the problem is when you're trying to return details about something, we're having to call this function every single time. If we have an int age, for example, and made that equal to 23, and we did console writeline and simply placed age inside the brackets, we don't have to do anything like this, because it simply just prints the value out. If we run the code, you'll see that it simply just says 23. This should be pretty simple for our person as well, but it's not. We need to call return details every single time we want to print the properties. And if we don't do this, the only way to do it is by making some string interpolation, and we can say person.name, and then also include person.age, etc., and then that can print out to the screen just like that. Of course, it doesn't have the same formatting, but we can also just take this, place it straight inside here, add our person dot before them, person dot, and there you go. Then you get exactly the same output as call and return details. But of course, you don't want to do this every time, and you certainly don't want to have to type in return details function every single time as well. You want to keep it as just person. Now of course, this is not going to work straight out of the box. Let's try run that and see what happens. So we get string override dot person. And what's going on here is it's saying namespace is string override, and then it's a class person. So it's just printing out this person object, but it's not really doing anything because we haven't really told it to do something. So what we can do here is we can actually override the toString method. So let me explain. So let me set up a couple of examples just to show you what's going to happen at the end. So right now we call return details to return these details. What we can also do is say .toString, and then we can also do these three options. Return the details, convert it to a string, or just print the person straight to the console. At the end of this little section, we're going to make all three of these print out the same values. So let's have a look now. ToString and printing out normally, these two lines right here are actually doing exactly the same thing. Behind the scenes, when you place anything inside these brackets inside a console write line, it will try and convert it to a string anyway, so whether you put ToString or you leave it as person, the console write line function will still accept it. So let's just comment out the age for the time being. In order to make the ToString function work, as well as just pasting person inside the brackets, we need to make a special function, which is an override function. So let's have a look. So just underneath our return details, still within the scope of the class, we'd say public, and then override. After we press tab, we can follow it by a space, and we can see the functions that we can override. So in this video, we're actually going to cover toString and .equals. Get hash code will actually serve as the default hash function. If I show you the documentation, it says here, a hash code is a numeric value that is used to insert and identify an object in a hash-based collection. This is normally used when you're doing hash functions, as it says here, and for the time being, we're not actually going to be using this right now. So the two we can do are toString and equals. But as you can see, our toString is available right now. We'll cover equals as an extension in a minute. So let's double click on our toString and we get this little template placed in. If you don't want the template, then it's just an override. It returns back a string since it's converting it to string. It needs to be this exact notation. If you drop the T, then it's got nothing to override. There you go, we get a compiler error because there's nothing to override itself. So we place toString in the capitals, there's no parameters passed in, and then we're going to be returning something. So the thing that we're going to be returning is exactly the same as our return details function. We actually have two options here. We could say return, and then return details. So what that will do is, it'll go to this function, it will call this function, grab that, and essentially place it inside here, and then return it back to the console. In the ideal world, we don't actually need this return details function. So we could comment it out, but I'm going to leave it in just so the demonstration doesn't break down here. So we can take this and place it straight inside here. Now we have two functions that essentially do the same thing. But the advantage is, this function is something that needs to be called explicitly, .return details. Whereas this function, the toString override, actually just gets called naturally without having to add any extensions. So if we run the code now, you'll see that now they all equal exactly the same value. We get three sections that have this. maybe we can place \t instead, just so we can have them all on the same line. There we go. So you can see all three are exactly the same. So what we can do now is if we comment this option and we comment out this function, we don't have to include toString if we don't want to. We can also comment this one out and we can keep it just as person. So as we do when we declare the integer, we say int age equals 23 and then we simply print it out. And this is exactly the notation that we want. It should really be this simple. There you go. One line creates the person and one line with just a variable name goes inside the brackets to print them out. The same thing here. Person, person, age, and age. And let's run that code now. And there you go. You get the person printed and the age printed exactly and straightforward as you may think it should be. So now that we've done that, let's explore what the equals function needs to be done. Let's make another person. We can say person test equals new person, and we can have Harry, age 23. Now we don't need to print them out in this example, we just need to demonstrate this equals function. So if you remember with strings, we can have a string called ABBA, for example, and we can say dot equals straight after it. And we can say if ABBA is equal to Harry, then we can do something inside here. What I'm trying to demonstrate is once you've got an object, you can place dot equals and then you can compare it like that. So you can also do that with our classes. So we can say person dot equals and then equals to test. And in here we could just say same. And let's try and make these as same as possible and see what happens. So let's keep the name exactly the same, just like that, and let's copy the 25 down just like that. So now these two are instantiated exactly the same way. Let's see what happens when we run the equals. Then we don't get anything printed, which means they're not the same. So because this doesn't automatically tell us that these two are exactly the same, we can override that and provide our own functionality, just like we did with the operator overload. We override equals, we get passed in an object, and we need to check something inside it. So let's see what we can do inside here. So in order to check if something is equal to another thing, what can we do? So we have a name and an age. If this one is the same as this, and this is the same as this, then two people are exactly the same. So let's try that out and see what happens. So we can say name, which is the property inside the class that we're currently inside, and then we can use dot equals because this is just a string parameter, and then we can say that equals to object dot name. But you can see we've got a little problem here. This object is very generic. It's just an object. Every class that you create is derived by an object. What that means is every class or integer or double at the end of the day is also just known as an object through inheritance, which we'll discuss further on in this course. But just know that everything inside C# is always an object somewhere down the line. So what that means is we have to convert it from an object to our custom class, which is person in this case. So we can use this thing called casting. So we can say person, which is just defining a new variable, and we can make that immediately equal to object as person. So what we've done here is we've said our object, which is this parameter, is currently an object right now. We want to cast it as a person, which is kind of like converting it into a person and then placing the values inside here. So now if we get rid of this comment, and instead of using object, we actually have a new local variable called person. So then here we can say person.name. There we go. Now we have access to the person property since we've converted this object into a person. And of course we know that we have name and age available. So if the name is equal to the person.name and the age is equal to the person.age, then we must have a match. And of course we want to keep using the properties, so we're going to use a capital A. And there we go. So we run the conversion on one line and then we check if they're equal to each other. Now in this specific case, you can actually pass anything inside here. So let's try it. We can pass 5 inside here, and as you can see, there's no compiler error, because like I said, 5 is just an integer, which is an object at the end of the day. If we make it a double, that works as well. There is literally no compiler errors. And even if you put m to make it into a decimal, again, there's no compiler errors because they're all objects at the end of the day. So let's pass test in there. What you will have to note is, if you do accidentally pass in a double, for example, like this, you're going to hit an error here, which will be a runtime error. It will try and convert it as soon as it hits this line, and obviously you can't convert a double into our person. So what you could do, just to wrap it around, you could say, if the object is a person, then we can proceed with the conversion, just like this. And then what you can do for safety is just outside of this, you can actually just return back false, just so the user knows that this isn't equal to each other. So if the object is a person, then we convert it as a person. Is used for checking, and as is used for converting. Is this object a person? And if it is, then we try and convert it and then return back if they're equal to each other. And if we accidentally pass something in that's not a person, then we just return back false. So let's just demonstrate this first. Not the same. So let's just say 5 inside here. It says not the same. So let's actually go into this, place a breakpoint, and let's run it again. Hover over object, then we get 5. If we place this straight inside the watch, you can see object is person is returning back false, so it's skipping this entire function and going into return false, and then it's returning back false, so we get not same. Let's stop the program, change this over to test, and rerun it using F5, and now we can see object is person is actually set to true. So now if we put the object inside here, you can see that generically it's an object. Right here it says object. So what we can do now is we can place person and down here as well. And you see that person doesn't exist, but if you just give it a second and we change this to just the P, there we go. So obviously the person doesn't exist because we're only up to this line. We press F10 and F10 again. So now it's created the variable, and F10 wants to skip over it. And now you can see the object has went from type object to type string.override.person. String override is the name of our namespace, and .person with a capital P is the name of our class. Now you can see that the object and the values are exactly the same, 25 ABBA and 25 ABBA, as you can see right here. So now both of them are exactly equal to each other. So when we check this, name here is ABBA, name here is ABBA, age is 25, and age is 25. So this must return back true, but we can check that by highlighting everything, dragging and dropping it down here, and we can see it says true there. So when it returns back to our code, it's going to go and print there same. Perfect. There you go. So that's it for this video, but let's just have a recap before we wrap up. So before this video, we'd always print the details out like this, person.return details, but obviously we don't have that function anymore, so let's just bring it back quickly. There we go. So we use return details, and this is just a bit long having to do this every single time. If you want to print the details of the test object as well, you have to do test dot and then return details again. It'd be so much easier if we could simply just use it like this, as you would do with a normal variable like an integer, double, a string, etc. And now it's made possible by using our public override string to string function. It will contain exactly the same contents as our previous function, except we won't have to go through an additional function just to print out the details. We can override the toString, and then we can call it straight in the console like this. And finally, when you're doing .equals inside an object, you can actually build in some custom functionality. We can convert the person using object as person, but first, before doing the conversion, you want to check if the object is indeed a person type before doing the conversion. This will give you a runtime error on this line. So let me just demonstrate that before we continue. So if I comment out this one and actually just change this into 5D, and then let's press into the code right here. It's going to hit this line if I press F10, then it's going to try and convert it, but you're going to get back null. And then if you run the code again, then you're going to exception thrown here. You're going to get a runtime exception because it's a null reference. We're trying to run the equals function on something that is null, which is right here, null reference exception. So you shouldn't do this. You should also make sure that these are correct values before doing it. This is a form of error checking. If you don't do this, then you're going to have to wrap this inside a try catch, and it will look something like this, and the code will be considerably longer. You can place these two lines inside here, and then place your catch inside here, etc, etc, and you can return false inside here. But as you can see, the code is a bit more complicated now, and there's no reason for this extra complication if you can prevent it with an if statement. So let's undo that. So what's best in this case is to say if the object is of type person, then we can run the conversion. If we run the conversion and it's not of type person, then as you can see, it's going to return back null for the person, and then when you run this line, it's actually going to return you back a null reference exception at this point. But anyway, the whole point of this equals is to check if two objects are going to be equal to each other. So if we keep this back to test, because this is a custom classes, you can't just simply do person equals equals test and assume that that will just work. These aren't built-in functionalities for custom classes. We covered operator overloading, where you can actually override what you do with the equal sign, but we didn't cover the dot equals, which is what we're doing today in this video, as well as the toString. This is a different kind of overriding because in the other one, when we're doing operator overloading, that's specifically an operator that you're just changing the parameters of, whereas this one is a strict override of a function equals and the function's toString. This will make it easier to print your custom classes out to the screen, as well as comparing them just like this. Person.equals, putting test inside the brackets, is a lot easier and quicker, and you can build in your own custom functionality. If you only had the age in there, then you can compare the age, maybe have a lot more properties, and you can always just chain them inside a big if statement. That's fine as well, but the point is you have full control over how you compare your custom classes. Maybe you had a list of names inside a dictionary, for example, and you wanted to add a new name, or a new age or a new user to this dictionary. But first, before you add a new user to the dictionary, you want to check if the user already exists. So maybe you could have a system where it uses the equals function and it loops through all of the dictionary items and it checks if all the values are not equal to this one. If you didn't build in this functionality so you could do the .equals function, then you won't be able to determine if this one is equal to this one. And now with your equals function overrided, you can now have the functionality to do so. Thank you for watching this C# course. I hope you found it helpful in your journey to becoming a proficient C# developer. If you have any questions or need further clarification on any topic we have covered, please don't hesitate to leave a comment below and I will do my best to assist you. For those of you who want to dive deeper into C#, consider checking out my Udemy course. You'll find more comprehensive lessons and hands-on exercises to enhance your skills. Remember, practice makes perfect. Keep coding and exploring, and I wish you all the best on your programming journey.